Howdy, y'all. I'm excited to present this open mic challenge to you all evolutionists out there. If you feel you can competently defend evolution, then come in and bring your arguments to Dr. Ken Hovind. The link will be pinned, and please tag SFT or me for any questions. Hit that like and subscribe button. I'm stoked to have the man himself, Ken Hovind, again with us tonight, as well as Standing for Truth. And I'm going to hand off to SFT for the rest now. And whenever you're ready, go ahead, SFT.
Yes, we've got the man, the myth, the legend, Dr. Kent, the science gent, here with us again. And I want to thank everybody for being here, not on the Standing for Truth channel, but on the Praise I Am channel, where we've been hosting about once a month these epic open mic discussions on evidence for evolution. So they've been tons of fun. They've been memorable. I'm pumped for tonight. Now, remember all, we prefer to keep these professional. We prefer them to be focused on one topic at a time. Any ad hominem attacks, anything like that, you'll get a warning and then you'll be kicked. We want to discuss the topic, which is evidence for evolution. So with that, Kent, good to have you back. I just saw you a few nights ago, brother, with your debate there with Grayson on the fossil record in the geologic column. That was tons of fun. So, Kent, how you doing tonight?
Doing great. Grayson still thinks he won. I told him, go buy yourself a trophy, man. You and put your name on it. He said, it took me a while to think about it. He said, French parents make French-speaking babies. Well, a French parent can take the child away and teach it any language in the world. Anyway, I'm ready to debate him again anytime. But yeah, I'm doing great here. Dinosaur Adventureland going well. We're having visitors come from places. We had a troop of Boy Scouts here a couple of days ago. Come on down, visit Dinosaur Adventureland in Lenox, Alabama.
Right, that's a good point. So Grayson said French-speaking people give birth to French-speaking children. Is the baby born with the ability to speak French? Bonjour. 1, 2, 3, 4, 5.
Yeah, oui, monsieur. Très bien, très bien.
Because I've got 3 kids and I've got 1 baby, and typically it's goo goo gaga. I don't know if that's French or English or what that is, but so Ken, tell me, over the last year and a half of debates on evolution, what have you learned from these evolutionists? Now we understand they believe they're related to strawberries, they're related to corn, they're related to what else are they related to, Kent?
I got the chart right here. Somebody made for me. Call Me Emo's related to a fly. Mark Drysdale's related to a monkey. Jackson Road related to a dinosaur. Mark Reid's related to a rat. Bill Nye's related to a banana. I got them all here. P.Z. Myers is related to a fish. We are fish, yeah. Wade the Wizard is a snail. And Luca Madugno is related to a cow. Ken Rock related to a turtle. TJ Jump related to a tomato. I got them all right here. Yeah. Snake was right related to a ladybug, and Professor Dave's related to a strawberry. They really, really believe they are. I don't know how to help them.
And they're proud of it too.
Well, Taylor, good to have you here.
Taylor K. Hi. And my ministry partner, Matt, from the Young Earth Creation channel, who is driving and ready to refute evolutionists while driving. That's impressive, Matt.
Yeah,
go for it.
It's that easy.
Man, it's awesome to see you, bro. Oh, gosh, it's been a while. Yeah, glad to have you on here.
Hey, Braze.
Matt,
and also
what are
Taylor,
your thoughts?
Good to have you too.
Before I hand it over to Taylor K, good to have you, Taylor. Matt, what are your thoughts after observing these debates over the last year and a half in the Evolution Debate Challenge, and what Kent just showed there with his board on how these evolutionists believe they're related to banana plants, they believe they're related to pine trees, to walking sticks. Is that science we're dealing with here, Matt?
No, it's a lot of hopes and dreams kind of based on what we were indoctrinated to believe in school. You know, we were programmed to believe that the hierarchical evolutionary tree of life that Darwin made up was true. And then as it started to fall apart and there's no single tree of life, they started to like reconstruct it and be like, oh, it's no big deal that we were falsified. We'll just invent something new. So now, of course, there's the 3-tiered domain of life rather than it's a bush of life rather than a tree. And then eventually that's going to fall away, because I've noticed that what they've done is they've cherry picked the data. They said, well, it's true that if we want to prove who's related to who and what's related to what, we need to look at three things: the Y chromosome, the mitochondria, or autosomal DNA. But when they want to prove relation outside of that, they can't use any of those anymore. They have to ignore all that, and they have to go to the protein coding genes. That's where they build these trees of life. They don't actually do it like they would do it from a paternity test, because it doesn't work, because we're not related to those things. Case closed, you know?
That's right, Matt. That's right. Well, Matt, appreciate you being here, brother. Taylor K from the famous channel that hosts the that puts out these awesome episodes, Questioning Evolutionists. Firstly, how you doing today, Taylor? Good to have you.
I'm doing great.
Secondly, how's your series coming along? How many episodes do you have so far?
Oh, I have 4 right now. 4 episodes.
Well, they've been a lot of fun to watch. You always ask good questions. And thirdly, if you got a question for Kent.
I have a
Go ahead.
question. I actually have 2 questions. I have a question for you and a question for Kent. So which one do you want me to ask first?
Start with Kent's question.
Okay. So Kent. So on creation day 1, God created light, but he didn't create the sun and stars until day 4. So what was the source of light before the sun and stars were created?
Great question. God is light. Jesus is the light of the world. I believe God purposely made light before he made the stars and sun and moon, so we would know not to worship them. Many cultures around the world worship the sun or the stars, and I think that's stupid, and God wanted to make sure his children knew he's the light, not the sun and the stars. They are the sources of light that light our earth now, but God himself is light. So God made it. God was there first, okay?
That was a great answer. I thought you might say that. Okay, so now my
Actually,
question.
if I could add one thing, Taylor, Kent, correct me if I'm wrong, a lot of these pagan religions, they worship the sun. And so it makes
Right.
sense for God in the Bible to have light before the sun, in order that we understand, no, the sun's not a deity. The sun's not something that we should worship. It's God alone that we should worship.
Correct.
Taylor.
Okay, so my question for you, Donny, is, okay, I have heard you say many times that almost all mutations are slightly harmful. How do we know that? Like, is it observable? And do you have any examples of slightly harmful mutations?
Yes, very good question, Taylor. Typically, when I argue for that the majority of mutations are deleterious. They must have some effect on fitness, even if that effect is small. It's kind of like a single spelling mistake in a book the size of an encyclopedia. One single spelling mistake on its own, it's inconsequential. But as these spelling mistakes build up over time, the message in the book is lost. It turns to gibberish. Or a single rust molecule on a car. A rust molecule on its own, inconsequential, but over time, as they build up, the car breaks down. And so it's the same thing in the genome. We accumulate roughly 100 new mutations per person per generation, and most of those being slightly deleterious, like that single spelling mistake in a book. And I will typically, to the evolutionists that deny that, Taylor, I will go to their own literature, where their own population geneticists and evolutionary biologists are admitting that, yes, most mutations are deleterious. Now, they'll say over time selection will solve the problem, but that's a whole separate argument, which also doesn't work. So I hope that helps, Taylor.
Thank you. That was a very good answer, too. Well, that's all the questions I have for today. Thank you for your time.
Well, Taylor, thank you for being here. Thank you for your great questions. I'd like to ask you a question. When are you planning on having your next Questioning Evolutionists episode out for?
I think we'll be in a couple, maybe like 2 months, because I have to, ask them questions and then get the responses to see if I can make anything out of them. But yeah.
Well, you always ask great questions. And correct me if I'm wrong, you were at Dinosaur Adventureland with your family relatively recently.
Yes,
isn't that right?
in January I went.
And did you have a lot of fun?
Yes, it was very
Good.
Yeah, the leap of faith was very fun too, the swing.
Good. Awesome.
Well, thank you so much for your time, and yeah.
Well,
Have a
thank
good
you,
night.
Taylor. God bless you.
Okay. Thank you.
God bless,
Bye-bye.
Taylor. Thank you for your questions. Join anytime. Okay, so our next guest, Centurion 737. Good to have you, brother. How you doing today? And if you have a question, go ahead.
Yeah, I have a question for Dr. Hovind and anybody that wants to take a shot at it. It has to do with the language of evolution. Why are we validating their language by calling things like the Jurassic and all that kind of stuff instead of dealing with it in our own biblical creation language, like with the strata and with all the other things that the evolution like to talk about? Why are we allowing them to control the description and not us kicking back on it?
You're on mute, Kent.
I didn't mute it on my end.
No, Kent, you're good now, brother.
You're
You're
good
good now.
now. You're good.
No, still says mute. Okay, there. Okay. I do not do that. It's a great question, and I don't glorify there is no geologic column, no such thing. All the layers are the same age. All of them formed at the same time. I use different illustrations to try to get them to understand. If you shuffle a deck of cards, does the top card become younger? No. Moving it from here to here doesn't change the date. I say, guys, if one layer is younger than the other, where did it come from? Outer space? There is no geologic column. So I don't glorify that. I don't talk about Jurassic and Triassic and all that stuff. It's all baloney. It's a fact the Earth has layers. It is not a fact they form slowly over millions of years. We believe they all formed from the flood in the days of Noah, but they're demanding we all pay for their religion to be taught. So I just say the geologic column is the Bible for the evolutionist. It can only be found one place in the world, and that's the textbooks. There is no geologic column. So great question. And some creation ministries need to stop doing that. You're right, giving credence to their stuff. We'll say during the Jurassic. There is no Jurassic age. Doesn't exist.
Yeah. I find that if we start controlling the narrative and stuff like that, it'll give more credence to our position than it would to theirs.
Right.
And I'll jump here really quick. I want to say thank you to Rock Roll for your super sticker with the KO. I love it. And then Mountain Hours with the Superheroes for Truth. That's what we got our little theme going on here. So I appreciate your support. God bless you guys.
And as a follow-up question, I guess, Kent, I'm curious. After moderating so many of these debates and seeing how the evolutionists respond, I've seen them point out in response to the geologic column argument, they'll say, well, we've got erosion. And so the reason why the geologic column is not found in any one place in its entirety is because rocks deposited during one period would be eroded away during a later period. What would be a good response to that, in your opinion, brother?
Well, they're welcome to believe that, but there are no soil buildup between these layers. All the layers are rock on rock on rock on rock. How's a tree going to grow? And we don't, just from a logical common sense perspective, we don't see this happening. All over the world, there are polystrata fossils, petrified trees that are standing up, connecting all these layers. They're everywhere, thousands of them. How long does a dead tree stand around in Canada before it falls over? A couple years maybe. But petrified trees that are standing up, this one's running through a seam of coal, then about 30 feet of rock, and then another seam of coal. Same tree, connecting them all. So the geologic column is the Bible for the atheist. It doesn't exist anywhere. We shouldn't glorify it at all. It's baloney.
Amen, brother. Well said. Great answer. The next argument they'll use is, well, we have countless volcanic eruptions that as a result have produced new material, new land, new mountains, new plains. And so this is typically where they'll say the new material comes from rather than coming from outer space. What would be a good response to that?
Well, it's not new material. It's recycled. It came out of the same earth, got puked out through a volcano. It's not new material. It's the same stuff. Moving it from here to here doesn't change the age of it. I don't know how they don't get it. Mount St. Helens was a classic example, a recent example, 40 years ago. It blew a bunch of mud down into a Spirit Lake and swallowed up all kinds of things. But as the mud flowed, it stratified into layers. These layers formed in seconds. The moon lifting the water up and down makes the tide go sideways underneath, and that's the sideways movement of the water that forms all the layers. All the layers we see in the earth were formed in 1 year. Maybe a few smaller patches since then, like volcanic eruptions doing a few square miles. But Mount St. Helens blew thousands of trees into Spirit Lake. They're still floating there today. And hundreds of them are floating in the upright position, which is logical. The root end is heavier. They're sinking to the bottom, and they're getting buried under layers of sediment. Every time there's any movement or shaking over there, new layers form, and the trees are going to be petrified standing up. So no, I don't glorify the geologic column at all. Go ahead.
Well said again, Kent. Appreciate it. And that's basically their two main arguments. They've both been demolished. So it's time to give up the geologic column, right, Kent?
Right.
Okay, so we've got Apologetics 101. Good to have you here, brother. I appreciate the work you're doing on your channel, the interviews you're putting out, and also your feedback in the chat. So since it's your first time joining an open mic, why don't you give a brief introduction into who you are? And then if you had some comments or a question, go ahead.
All right. Can you hear me okay?
Yes.
Sound good.
Awesome. Hello, Kent. I've actually had your son on my channel on my Genesis series as well.
Hey, good.
My name is Brian Bowen. I have a channel called Apologetics 101. Right now I'm doing a Genesis series, actually, a really big Genesis series. It's going to last another couple of years before I finish it. But you're right. It's like a commentary series on Genesis. But my channel is basically a Christian apologetic channel in general. I do a lot of stuff on stuff like that. But this is the biggest series I've ever had on my channel as far as the Genesis series. I do have a question, and I know that Donny, you had a recent debate on your channel concerning Australopithecine, and there's issues of whether or not if that even really exists or not. And I'm just wondering, what exactly is y'all's position? I didn't actually see the whole debate. I saw part of it, but I didn't see all of it. Is it your position, or even Kent's, whether y'all deny that it exists, or what do y'all think about it?
That's a good question. So basically, what are our overall thoughts on Australopithecus, or specifically Australopithecus afarensis, which many know as Lucy? Okay, Kent, what are your overall thoughts on Lucy and the Australopithecines?
Well, they certainly did not find anything near a whole skeleton, and it was obviously, I think, about 3 feet tall. It would be in the chimpanzee group easily. Had it been walking around today, nobody would think anything about it. They'd call it a chimpanzee of some kind, a monkey, and certainly in the monkey family. And I point out all the time, if they find bones in the dirt, you don't know they had any children. All you know is it died. You could not prove those bones had any children at all, and you certainly couldn't prove they had different children. If Lucy was an unusual-looking ape, so what? There's unusual-looking animals born all the time. Unusual horses, unusual cows, unusual people. I've seen some screwball-looking people out there. They're still people. So they're so dead. I ask atheists, guys, why do you keep thinking a bone in the dirt can do something no living animal has ever been able to do? Nobody's ever seen any animal produce something other than its kind. Cows make cows, dogs make dogs, goats make goats. There are no exceptions. Why do you think this bone could do it? It's a bone in the dirt. It's so you named it Lucy. She doesn't care, or he doesn't care, whatever it is. He doesn't care what you call it. And no animal today is able to do this magical gift they give to the bones to produce something other than their kind. God said they would bring forth after their kind. He said it 24 times in the first 7 chapters. I think he wants us to get the message. That's all we've ever seen. That would be science. They bring forth after their kind. Lucy was probably just a 3-foot-tall chimpanzee, nothing more.
So you wouldn't claim that it didn't exist necessarily, but you'd say that what evolutionists claim about chimpanzee is mostly their imagination and assumptions.
Well, they are desperate for missing links. I say, guys, the whole chain is missing. It's not just there is no chain. What missing link? Show me an animal today producing babies that are different, that are going to lead to a totally different kind of animal. We see animals that have a very short lifespan, like there's certain bacteria that go 8 hours. They're born, grow up, get married, have babies in 8 hours. Well, you can study thousands of generations of those in one human lifetime. We never see them produce anything but a bacteria. When you get to something like a monkey where they've got, what, a 2-year generation time, well, that's going to take trillions of years to do anything. It's just nothing but imagination.
Donnie, what's your thoughts on it?
That's a good question. I would agree with Kent that what they basically find in terms of the ape-like bones would be an extinct type of ape, like a chimpanzee. And it's all based on pretty flimsy evidence. For example, here I have a chart breakdown on what you're looking at. As Kent pointed out with Lucy, it's very incomplete, not even close to the 40% that they would say. And I've got quote after quote. I've actually had some correspondence with Ella Bean. She's a well-known paleoanthropologist. And a lot in the field have actually recognized that a lot of these so-called pre-humans, like Australopithecus sediba, Australopithecus afarensis, I'm trying to find the slide here, but I've got a lot of stuff. They'll recognize that oftentimes in these bone beds, you get a mix of human bones and then ape-like bones. And so a lot of these creatures like sediba, for example, end up being artificial, as in they're not real. It's the accidental combination of ape and human bones. And even Donald Johanson recognized years and years ago that there's significant overlap between your Homo genus and then your Australopithecus, which would just be an extinct ape genus. And so many in the field of paleoanthropology have recognized this, and it really is just a weak science. It's low quality, it's low confidence. And many in the field have actually recognized that there have been misplaced bones in the Lucy collection for 40 years. It took them 40 years to recognize that one of the vertebrae actually belonged to a baboon. And so they had to remove it out of the collection. It took them 40 years to recognize this. And many have recognized that the sacrum, for example, has been mixed in. That belongs to a human. Some have suggested that the knee that was found miles and miles away is human as well. And so I believe overall we're looking at a mixed collection, human and ape bones that have been mixed together. So I hope that helps.
Yes, I heard something or read something. I don't know. Are you familiar with Bones of Contention by Professor Marvin Lubenow?
Yes.
I read something in there, something about Australopithecus habilis, something like that, being like a collection of human and ape mixed together.
Right.
I also heard that the kneecap of Lucy was actually found away from the fossil. Is that correct?
Yes. Yeah. A lot of the bones attributed to Lucy and a lot of the bones attributed to habilis are actually legit human bones. And so there's been at least one paleoanthropologist in the field who called habilis a wastebasket taxon. It's just a garbage bin of bones. They don't know what an ape bone here, a human bone here. And it's not, I'm not saying it's like Piltdown Man where it's an intentional hoax. It's just the accidental mixture because you have overlap and intermingling with these ape species like the Australopithecines and also humans. So anyways, Ken, any thoughts? And what are your thoughts on bones of contention?
Right. They're still missing the bigger picture. We should not be arguing about these bones at all. I mean, it's obvious you're right. There's a mixture of things are mismatched or misidentified or deliberate frauds. But no bones count. None of them. Even if you found a complete fossil of a creature that looked half human, half ape, you could not prove it had any children. You could simply argue it's some type of creature that's gone extinct. How many animals have gone extinct in the last few hundred years? There's extinction. That's the opposite of what they need. They need something creating something new. It's never observed. It's not science. It's a religion. They believe it. That's all. Nothing more. What happened to atheist, what's his name? Pipsqueak? Junior. Bring him on. Go ahead.
Atheist Junior, one of your #1 fans, he told us he's joining. So maybe he's doing some last minute prep. I'm not sure, but the link is posted in the chat, everybody, to join. And we'll have some fun. We'll keep it one topic at a time. We'll keep it fair. As a matter of fact, Andrew has joined us, who does hold to the evolution side. But before we hand it to Andrew, of course, Apologetics 101, brother, if you had any follow-up questions or any final comments for now, go ahead.
Yes. I was going to ask something about the feet. I know the feet wasn't found with Lucy, and that but sometimes they say that there are some bones found of the like other Australopithecine or Pithecus. What would your response to that be?
It's up to Kent. Well, I will say this. I'm going to screen share. I find it fascinating, the Laetoli footprints. And so they found these footprints right here. Notice this. This is the Laetoli print. Looks identical to human footprints, right? You've got the inline big toe. Everything about it represents what? A human footprint like you see here. You can see your chimpanzees, your gorillas, your orangutans, your baboons. Their feet are a lot different than humans, but it's circular reasoning. So the evolutionists like Mary Leakey, Donald Johanson, so on and so forth, they reason, well, humans didn't exist 4 to 6 million years ago, so these can't be human footprints. And so they must belong to an Australopithecus type like Lucy. And so you're right. As far as I understand, they didn't really find any bones associated with Lucy with the feet. But when they did find these footprints, they said, well, these must belong to a pre-human like Lucy. But anybody looking at the footprint, even the discoverers of these footprints or the paleoanthropologists at the time, they said these look exactly like or very similar to modern human looking footprints. So I would say yes. What they've attributed to being Lucy's feet or Lucy's footprints actually belong to humans, and I think that's clear in this picture. Kent, any thoughts, brother?
Well, yeah, Russell Tuttle at University of Chicago studied 70 people that go barefoot all the time. We found a tribe of people, they never wear shoes, and they start to get a little separation between the big toe and the other toes to spread the weight out of their as they walk and balance. He said there's no difference between the Laetoli footprints and these people that go barefoot all the time. They're human footprints. He said if we didn't know they were so old, we would think they're made by a member of our own genus. Wait. If you didn't know how do you know they're so old? This is where the problem comes in. That stupid geologic column is a great hindrance to real scientific study. The Laetoli footprints were perfectly normal humans. Somebody goes barefoot all the time. Now, when they did it for National Pornographic, they added the toe separation, put it way out further because the chimpanzee toe sticks out to the side. So this is just pure propaganda is all it is.
Awesome. Thank y'all. I appreciate it. It does sound like they're begging the question there. All right. That's it. I'm going to go ahead and take off. I got to work tonight. But thank y'all for your time. I plan on doing some videos about Lucy and so forth in my Genesis series. So I appreciate y'all's comments, and I will talk to y'all later.
Take care, Apologetics. Thanks for coming in.
Thank you. And Donny, I'd like to get your slides that you've got. You did a lot of research on this stuff, and send them to me. I'll add them to mine. I'm busy on so many other things here. I don't keep time to get caught up on every detail. But Mark is here to get converted. Yay!
I'm out here to deconvert you, Ken. I think today's the day you're going to be deconverted. I think today's the day where you're going to actually see reason. So I'm very excited about it. I really am. So the interesting thing about Lucy is Lucy didn't have feet. Yeah, and that is true. But Littlefoot did, and Littlefoot is way more complete than Lucy ever was. Like, that is a way more complete skeleton. It's just Lucy was the first found. That's why that particular fossil is so famous, because it was the first Australopithecus we actually found. But what's more interesting is sort of, even though the feet are very similar to humans, the obviously it's a bipedal creature. There's other factors in the makeup of it that are definitely ape-like. So how do you explain the ape-like features that we have with the structure of the jaw and the cranium and things like that?
Well, I'd have to see the evidence and not take your word for it. And just because something is ape-like, I think, humans have hair, apes have hair. Does that make sense? Horses have hair too, I believe. Yeah, they do. And our donkeys do. And our goats, they got wool. But so you're claiming these similarities prove an ancestry. No, it doesn't. It could prove a common designer. You don't know it's a common ancestry. You're so desperate for something to prove common ancestry because you don't want to believe in God. Well, that's fine. Keep your religion to yourself. Teach it to your family if they want to learn it, but I don't want to pay for that to be taught in schools. It's a religious belief to believe that animals have come from a common ancestor, which was a bacteria-type creature, which came from a rock. That's a religious belief, Mark. I wish you could see. You've chosen a really dumb religion to believe in.
Yeah, so the whole idea that horses have hair and humans have hair, horses aren't bipedal. That's not how we categorize anything. So like when you're talking about categorizing things into sort of a systematic way, yeah, things have hair, but it doesn't mean they're closely related. Like we're looking at things like the bipedality, the shape of the cranium, like these things you can't say, hey, because they have hair, they're near a horse. This is obviously quite a lot similar to a human, in fact, more similar than a chimpanzee. And for your second thing, what I think is I want to know your definition of a religion, because you've made that claim that it's a religion. But I don't know what definition you're using. So can you define what you mean by a religion for me?
Well, Donny, I'd ask that you enforce the rule one topic at a time. He just threw two things in there quickly, so I would not have time to answer
You brought up both those things. You brought up both those things.
One at a time. Animals that have similarities prove a
common
common
one at a time,
designer.
Ken.
Animals that have similarities prove a common designer, not a common ancestor. In your mind, everything proves common ancestry. In my mind, I see common designer with all these similarities. If they have similar hip structures, well, the hip is very complicated, extremely complicated. You really believe all the curves and muscle attachments and ligaments and sinews attached, and they all happen by chance over billions of years? Where's the evidence for that? So my definition of a religion is something you believe in by faith, but you don't have any scientific proof for it. You can believe all kinds of things. There's people who believe in UFOs and people who believe in the Tooth Fairy and Santa Claus and Easter Bunny and evolution. They're all religions, nothing different. See, the difference is you're demanding that we all pay for yours to be taught. That's the difference, isn't it, Mark?
Yeah, so I don't believe in evolution by faith. There is a ton of evidence for it. And you might sort of sit in your little religion where your book is right and go, hey, that's not evidence to me. That's fair enough. Okay, you want to ignore all the evidence? That's fine. That's completely on you and your little religion there. But that is scientific evidence that has been peer-reviewed and gone through the ringer of scientific fields. So it's completely based on evidence, not a religion. So your definition does not apply to evolution. The whole idea that the hips are
before you go on.
Okay, let me jump here. I'll make a recommendation.
Okay, so
if Mark,
before you go on, hey, no, don't slap and run. You made a statement, and I'm going to answer it before you go on to something else. You
brought up two things.
Shut up, please.
You brought
Mark,
up two things.
My turn to talk. Okay, shut him off. You said there's a ton of evidence for evolution, and now you want to go on to something else. I'd like to see one at a time. What evidence are you talking about? What is just the single best evidence for evolution? You said there's a ton of it.
Retroviruses. Yeah, endogenous retroviruses are the single best
endogenous retroviruses.
Evolution, yes. And just quickly, no one's saying evolution happened by chance. No one's saying that.
Donny, he's doing it again. He makes a statement and goes on to a new topic. Stop him, please.
I didn't bring up evolution was by chance. You brought that up, Kent. This is what you do. You gish gallop, and then when I address your points, you say that I'm bringing stuff up. You brought up evolution by chance.
Okay, I'm going to jump in, guys, and just give my recommendation. So it's kind of hard to moderate because there are several points on the table. And so let's now start fresh. Okay, so we've had some fun, so back and forth. Let's start fresh with one single point, and we will just go back and forth on that. Mark, I know you want to say something, so let me
Yeah.
unmute you. Go ahead.
I'll just say one thing. If Ken only wants to talk about one topic at a time, then only bring up one topic at a time. Stop bringing up multiple topics, Kent, or else I'll talk about multiple topics. It's all on you, buddy. It's all what you decide to do. But if you bring up multiple things, I will address multiple things. If you don't, I'll just address the one thing. Simple.
Okay. You said the best evidence for evolution is endogenous retroviruses.
Yes,
You
absolutely.
apparently are not aware of how complex the DNA code is. It is unbelievably complex. Endogenous retroviruses are not evidence for evolution. They are a part of an extremely complex code. And people have debated this before with you. Endogenous retroviruses, the millions of viruses in the world laid end to end, would stretch 100 million light years. Microorganisms live harmlessly on and in our bodies. They outnumber human cells by 10 to 1, playing a vital role in human health. And just because it's a virus, that word does not mean it's bad. Viruses can be good, okay? Viral genome hits the trash. ICR has a great article about endogenous retroviruses. I'm sorry, they are not evidence for evolution. For you to just say that big fancy word, endogenous retroviruses, people say, oh, wow, he's smart. He knew a big word. That must be proof. No, endogenous retroviruses, there's a long answer to this on quite a few websites. They are not evidence for evolution. How do you think they prove evolution? They're incredibly complicated little tiny machines, the viruses are. So no, I'm sorry, you're mistaken. That's not evidence for evolution. We could do a whole debate just on that if you'd like. What's your second best evidence for evolution?
I'll address that actually. We're not moving onwards like you would say, slap and run kind of thing. So humans and chimpanzees share 205 different retrovirus elements throughout their genome. Most of them, well, and all of them, although those 205 are in the same place and are the same viral sequence. You have to explain how those viruses got there, because the only way a virus can become fixed in every single cell, and these 200 viruses are in every single cell of your body and every single cell of a chimpanzee's body, is if the germline is infected. That is the only way it can get into any cell. So how did the germline of both humans and chimpanzees get infected with the same virus at the same insertion point, right? The same insertion point, same virus. How did that happen if it wasn't an infection before the endogenization, which is the passing down vertically of that virus, happened when we had a common ancestor? How did that happen?
Mark, actually, and before you respond, Kent, I think if I could reiterate a little bit, Kent was going over some of the important functional roles associated with ERVs, right? Placental development, determining cell types, acting as antiviral protectors. And so if we share 205 with the chimpanzee,
yes,
then therefore they would be shared because of shared function, shared purpose. They were created that way, essentially.
Well, what we see, like in the AIDS virus for SP1, is the AIDS virus basically is co-opted to provide a immune response towards that virus. Like, you must have seen this, Donny, that you can actually co-opt a virus, and I've got thousands of papers on this, mate. You know I have.
Well, so
of the
do I.
co-option of viruses to provide beneficial functionality, including the Phoenix virus called Phoenix Rising, where they took one of these retroviral elements. It was HERVK-HML2, and then resurrected the virus from that viral element that is present in both humans and other animals.
Okay, I can respond to the Phoenix virus experiment easily, but I do want to hand it over to Kent in case anything he wants to add,
well, Kent seems
just so we don't have
nah,
too many points on topic.
He just said no. That's his entire argument. So,
Are
Kent,
you done
go ahead.
talking?
We'll keep it on.
Okay. If there are similarities between us and chimpanzees in the DNA code anywhere, whether it be in viruses or in the code how to make a finger, how to make a nostril, how to make an ear, we have similar designs because we have a similar designer. God created everything. As I've said thousands of times, the Microsoft PowerPoint program contains, I don't know how many lines of code, And Microsoft Word contains a lot of lines of code, and probably tens of thousands, if not hundreds of thousands or millions, are identical lines of code. When I go to spell check in Microsoft PowerPoint, it takes me probably to the same dictionary that it does from Microsoft Word, because the same guys are writing the code. I think God wrote the code to make a chimpanzee, and it's incredibly complex. And God wrote the code to make a human, and it's incredibly complex. And all we've seen is degradation over time. Mutations come in and cause problems. We're building up a genetic load. This is the opposite of what evolution needs. You need to turn an amoeba to a chimpanzee. In your mind, because they have similar insertion points, therefore they got to be related. No, the same guy designed them. They serve a similar function. Maybe there's more yet to be discovered about it. But you've already closed the case in your mind. It's proof for evolution because you're desperate for your religion. Go ahead.
No, it's simple induction, Ken. It's simple, like looking at the evidence and making a rational and reasonable association with that. You don't want it to be real because your book says a thing and you want it to be right. You are a fundamentalist religious person, so you can't accept this. But we have activated the EMV2. We have reactivated that in mice. So what you're trying to say right now is that God designed it in such a way where it has the GAG ENV pole structure, it has the long terminal repeats, which is only caused by the integrase making a cut in the DNA to insert that retroviral element, and that we can reactivate it into a fully infectious virus. It will spread to other cells, and we have done that in the Phoenix Rises thing. And all of that was done to have some sort of other function where everything tells us that that was co-opted by the virus mutating, just like we have seen the HIV virus mutate to provide an immunoresponse when it does mutate into the SP1 variation. And it doesn't explain how they got there. I just want to say that. It doesn't explain how they got there. It's just magic or something. I don't...
Okay. Well, we need to have a whole debate just on that, I suppose. Donny, you've done a lot more prep on that than I have on this endogenous retroviruses, because this is his favorite one. What do you have on that, Donny? I'll turn it over to you.
You asked for my best evidence. That's my best evidence. If you don't want it, don't ask for it.
We can set up a whole debate on ERVs between Mark and Kent. I can give a few thoughts. Mark, you can respond, and then we'll allow maybe ourselves to get into a second topic. And Mark, you and I can certainly engage it more in the future as well. We've discussed.
I'd love to set up a debate on retroviruses with you, Donny. That would be awesome.
And you and I'll just respond to a couple things. You and I, we've discussed the escapee hypothesis in relation to the origin of retroviruses in general. The problem for the evolutionists is they have this chicken and egg problem. They have this unsolvable paradox, because the question is, if a retrovirus requires a host to replicate, what came first, the retrovirus or the host? And so the creationist, like myself, we've suggested that your retrovirus is actually originated from host DNA. And that would partly explain why we share the exogenous retroviruses like HIV share sequence similarity to ERV sequences, since exogenous retroviruses occurring from outside like HIV would have originally originated from host DNA. So here on the screen, you'll notice the structure of your ERV. You got your LTR on either side, like you pointed out. You've got your host DNA on either side as well. LTR stands for long terminal repeats. They function as promoters in the human genome on a large scale. In the middle of your ERV, in the middle of your LTRs, you got your GAG, your pol, and your ENV. Your ENV is your envelope protein, and your pol codes for the reverse transcriptase, which reverse transcription is what requires when an exogenous retrovirus infiltrates the genome. And also these elements here, part of the structure, they're required for many of the functional roles associated with ERVs. including jumping around the genome, inducing variation, acting as antiviral protectors. They require these structures, these sequence similarities to exogenous retroviruses, the LTRs, the GAG, the POL, the ENV, in order to carry out their role in viral mimicry. They have to look like the viruses in order to fight off the viruses. And so that's why they share sequence similarities with these viruses. Last thing you said was the Phoenix virus experiment, where they resurrected a dead virus. Yeah, that's completely in line with what we're saying in terms of the escapee hypothesis. If your exogenous retroviruses originated from host DNA, then of course, through these kinds of experiments, we'll be able to resurrect dead viruses, since those exogenous retroviruses originated from the host cell in the first place. And I would argue that's the better explanation, because the evolutionists can't explain where retroviruses or RNA viruses came from to begin with. They really lack an answer, where I believe the creationist has an answer, and has a very good answer. So go ahead.
Well, I think that the best hypothesis is the virus first one, the RNA world kind of thing hypothesis. I think that is way better explanation than a forming within the own thing. Now, it doesn't really matter where they came from. It doesn't really matter. So your hypothesis is that those viruses started in the host, but the problem with that is we never find a viral sequence with the ENV GAG POL without long terminal repeats. We never find any viruses without those insertion points. So you cannot point to any virus found anywhere in these DNA sequences that have just the virus and not the LTRs. You can't point to that.
Can I interject here quick, please?
Yes. Okay. So we're going to let Otangelos speak, but I will say, since we have Kent for the first 2 hours, I want to make sure Kent, being our guest, is as involved as possible. So maybe a little bit more on the topic of ERVs, and then we'll try and shift it to another topic. After the 2 hour mark, we can certainly get back to ERVs. But Otangelo, feel free to add a couple points if you'd like.
Yeah, two things. I think in order to claim that chimps and humans have a common ancestor, you cannot just look at one point. Like, for example, humans have a completely different wiring of the brain and gene regulatory network, which is unrelated completely.
Well, actually, Otangelo, I'm going to jump in. I appreciate your point, but we do want to keep it on endogenous retroviruses currently before we move on to another topic. So if you had anything to add in terms of what Mark was saying, then feel free to do so. If not, maybe wait to make those points until we get on a topic similar to that. Otangelo, go ahead. Anything on ERVs that you'd like to add, Otangelo?
No, I was secondly talking about what Mark just said about the origin of viruses, which in my understanding completely falsifies the theory of evolution, because one of the main tenets is universal common ancestry, and science itself confirms and doesn't dispute that viruses do not have and do not share a common ancestor with cells. So this is a big problem, because you don't have to explain only the origin of life, of living cells, but as well the origin of 7 different lines of viruses. And viruses, they have capsids, which are completely unrelated shells to cells. And they are very complex bacteriophages. They are literal killing machines. They're hyperly complex, and they need an explanation as well. And evolutionary theory doesn't have any explanation whatsoever, and the RNA hypothesis doesn't have either.
So congratulations, you've completely failed to address what I've said in any way, shape, or form. It doesn't matter what their origin is. The point is that we get these endogenous retroviruses which provide a nested hierarchy that go down. Like, there are endogenous retroviruses that humans share with fish. 100% share with fish, and I could look them up as we go. There's endogenous retroviruses that all mammals share, like the one for the placenta. There are endogenous retroviruses that just mice have, right? So what we have, what we end up seeing is a nested hierarchy of retroviral elements that show that they were infected at the germline in the same place by exactly the same virus, and we know they're infected because of those 2 LTR regions on the sides of them. So you've got to explain how they got infected at the same place by the same virus over multiple different species, sometimes thousands of species, if they were designed separately. That's what you've got to explain.
Okay, let me address I want to give my thoughts on the nested hierarchy argument. We'll get Kent's thoughts on the nested hierarchy argument as well. We'll kind of go back and forth, Mark. I appreciate your points here.
Yeah,
so when it comes to these nested hierarchical patterns, yes, as you can see on the screen, humans share more ERVs with the chimpanzee than humans do with the mouse. Now, the question is, are endogenous retroviruses and retroviral-like sequences like the solo LTRs you're talking about, which solo LTRs represent the majority of so-called ERVs in the genome. I've got paper after paper here. I don't want to lose my spot. Solo LTRs, functional stretches of DNA that go over from the secular literature that solo LTRs are very important to the genome. And so I would argue they are not representative of degenerated ERVs, but actually functional stretches of DNA. And so if endogenous retroviruses and endogenous retroviral-like sequences actually represent created units of DNA function and not the ancient remnant of past viral infections, then of course we would share by definition more of these created units of DNA function with the chimpanzee than we do with the mouse or a fish, because overall in morphology, physiology, and anatomy, humans share more with the chimpanzee anyways. And so the underlying genotype should also reflect that. So I don't think the nested hierarchical argument is all that strong. If the majority of ERV sequences are created, the hierarchical pattern of distribution makes sense. Go ahead.
So, Donny, just a quick
I'd like to show
question.
something as well, Donny.
Just quick question. Do they not have function in gene regulation?
Yes, endogenous retroviruses have function in regulating cell immune activation. They have function in gene expression, determining cell types. They function in the embryo. There's one specific paper that me and Mark have gone back and forth on, where the secular researchers literally admit that if we didn't have HERVs, human endogenous retroviruses, mammals wouldn't exist.
Yeah,
because
I think it's the SIRH retrovirus from memory. You'd have to check me on that. SIRH, I think it is.
Yeah, I've got the paper here somewhere, and it talks about how if we didn't have that specific ERV in humans, I think it's right here actually, right here. Notice this: HERVs appear to play important roles in physiology, fetal development, and human evolution. Of course, they're going to throw that in there in secular literature. When they say human evolution, what they oftentimes mean by that is these pre-existing ERVs, because they can jump around from one chromosomal location to another, that actually induces genetic variation to be passed on to the next generation. That's actually beneficial in a design model, okay? It says here, if the accidental infection of a mammalian ancestor, again, they're assuming millions of years ago, some ancient mammal ancestor was infected with an exogenous retrovirus, we as a creationist, we would say the ERVs are functional and therefore created. So we would reject that idea. Anyways, they say the placental and the mammals that produce it, including humans, would have never existed. I like to exist. Mark likes to exist. Kent, I know you like to exist. And so the point is, and so exactly. So I would argue if we share these HERVs with the chimpanzees, with fish, with mouse, with vertebrates in general, then that makes sense, because these HERVs are required for us to exist. From a design perspective, from a design model, that makes complete sense. Go ahead.
Yeah, could you share my screen, Donny? So this is what I was talking about with the HIV thing, how we see co-option through mutation of these endogenous, these retroviral sequences. So this is mutation in the HIV co-receptor. So it's a CD4 receptor that basically, because mutation can happen anywhere in the cell, what happens is it mutates the retrovirus itself, and then that provides a benefit for the organism. So what's the benefit? Well, this provides a immunity to HIV or resistance to HIV infection, basically. It provides an immune response. And this is a mutation that we have actually observed. It's evidence that we see. It is mutation in the HIV co-receptor, right? So we see this. This isn't sort of like, oh, we speculate. This is stuff that we see, okay? So my question is, why is it that you think that it was placed there when we not only have evidence of the LTRs formed when retroviruses infect a cell, we have the mutation that we can observe of retroviruses, of retroviral elements like HIV, that shows that they can have a beneficial effect if they do mutate to show a beneficial effect. Why would you then say, hey, it was put there by God or something?
Okay, so a few things. The HIV virus is an exogenous retrovirus, so it would be passed on horizontally. It occurs from outside. Your endogenous retroviruses, the pre-existing ones that exist in humans and chimpanzees that you say we share, well, those are fixed. That means every single human has them, every single chimpanzee has them. So that's different than your HIV virus, which is occurring from outside. It causes disease. Nobody wants HIV, which is the precursor to AIDS. Okay.
But
The
don't you
target.
see
Let me just say this: the
Yeah,
target
okay,
site,
sorry.
the target site duplications (TSDs), you'd get those same signatures, Mark, whether you have an external infection. Okay, you're going to
Yes.
get target site duplications. You're going to get LTRs. But you're also
Yes.
going to get those same signatures when an endogenous retrovirus or other classes of retrotransposons move within the genome from one chromosomal location to another. You're also going to get those same
Yes.
signatures. And so the question
Yes,
is,
but
the signatures we're looking at, are they due to external infection like you're talking about, or are they due to the pre-existing function of your jumping genes, essentially? Does that make sense?
But the problem is if it's an exogenous retroviral element that's moved around, that HIV virus, for instance, the one that we're talking about, will not infect the same place in the genome. It looks for an insertion site and it doesn't specifically target the same insertion site. There are sites that it favors, like sites with low chromatin, for instance, but that isn't something that is like, to have every single organism in a species be infected in exactly the same place in the genome. The chances of that happening from an exogenous retrovirus it's ludicrous. I'm really sorry, Donny, but it can't happen.
Well, it's only if you assume that the majority of the ERV elements that we see in the genome, which are, by the way, solo LTRs, long terminal repeats, I am arguing that the majority of those, which comprise thousands and thousands of them, not your full ERVs, right? LTRs, GAG, POL, ENV. Those represent functional stretches of DNA. And so I don't have to explain how all of those occurred independently as infections between in the human line and the chimpanzee line. I'm saying they were created that way. Now we do have a few unfixed ERVs where only a subpopulation has them.
Yes.
And so I would agree with you that those are due to true infections that made their way through the germ cell lines and were passed on vertically. But that's a very rare occurrence. The majority of what we're looking at are fixed ERVs where all humans have them and all chimpanzees have them. And so I would argue those are fixed, therefore they're functional and thereby design and not descent.
Would you at least concede that even though this HIV mutation is not fixed in the genome, that if it was a lot more prevalent and we're in the wild, then it is possible for it to become fixed?
It would have to reach fixation.
Right.
I believe there are some ERVs in the population that are at about 90% frequency, rather than the majority of them that are at a very, very low frequency that'll probably never reach fixation. So if you had a bottleneck, if drift was working effectively, then hypothetically you could get the fixation of an endogenous retrovirus in real time.
Right.
But we'd have to see that. We'd have to study it. We'd have to see if that has gained a function. You're saying this HIV exogenous retrovirus, this is just a mutation in the exogenous retrovirus, right? It's not a
right.
Okay, so it's not.
But
Oh, go
what
ahead.
would stop a mutation in an endogenous virus that would become fixed through that animal having a benefit? Like, because this is obviously beneficial.
So you're arguing, I'll have to read this paper. You're saying you have the HIV virus, which is a horrible virus, leads to horrible side effects, precursor to AIDS.
Yes.
You're saying in the co-receptor, there is a point mutation that altered it to the point where whoever it occurs in is now immune to HIV?
Yeah. Well, highly resistant. Yeah. Yeah.
So they have to get the HIV virus, and then that virus in its co-receptor has to be hit with a mutation, and now that individual becomes resistant to it.
Yeah.
Okay. I mean, it sounds interesting. I'll have to read the paper.
Yeah.
But
Yeah. I can send it over. That's no problem.
I'd be curious, because if they're infected with HIV horizontally, it's not long before that HIV virus results in some pretty serious side effects.
Oh,
so is there a
yeah.
waiting
So
time before it gets that mutation and the individual can become resistant?
So essentially what has to happen is the virus has to mutate in such a way that it is not, because don't forget that a detrimental effect in the virus, as long as that organism can procreate, as long as they can get their offspring out, if it's something that occurs later in life, like we see a lot of viruses that cause aging, for instance, like later in life, they might cause Alzheimer's or aging or some of these detrimental effects. But if that organism can get to procreate, it's not going to have a significant impact on it. Now, so as long as it can get its offspring out. Now, it also, that mutation, as we see in a lot of these endogenous retroviruses, they may be completely nullified. Like the retrovirus doesn't do anything. And that's the same in the Phoenix Rising one, where it doesn't do anything. We reactivated the virus by, using CRISPR to change some of the sequences, and it just came back to life. It doesn't do anything, though. You could replace it with anything and it wouldn't change a thing. So not all of these retroviruses do something, though a lot of them do, I will grant you. But yeah, so as long as that organism can get to procreate, that virus can be fixed in the population regardless, as long as it's not too detrimental. And of course, if it is too detrimental, it will be eliminated from the population and, wiped out. Then the virus won't be promoted, won't be fixed. It is only the ones that provide a benefit or, are innocuous, they don't do anything, that are fixed in the organisms.
Fixation rates are very slow. Basically, this exogenous retrovirus, the HIV exogenous retrovirus, it would have to infect. It would have to be hit with that mutation that leads to this beneficial, this benefit essentially. Then it has to make its way in the germline, though. That's the problem. Is these are horizontal. Like your HIV virus is infecting through somatic cell lines. If it hit in the germ cell line and got passed down vertically, now every single cell of the progeny has the viral DNA, right?
That's
so
right.
Has that happened?
I don't know. I mean, I can't see that, but I don't see any other way for that virus to get into the every single cell of your DNA. Like there is no way for that to happen apart from replication of the original cell. Now, regardless of whether you think a god put it there or whether it was a endogenous retrovirus or a retroviral element being inserted, there's still no way around that, because you've got to replicate that same positional location throughout every single cell. The only way to do that is by replication from the original cell, which is the germline.
I will say this. I do want to make sure we get Kent back in for you and him to go back at it, because Mark, we can do this for hours. They've been able to track back the HIV virus in humans to chimpanzees where it exists as the SIV virus. And from my understanding, they've been able to track that back to, it might be a mouse species, some other mammal species where it's not harmful. And so basically what I was saying earlier with the escapee hypothesis, the host that these exogenous retroviruses originated in, they would not actually be harmful to the host. They would become harmful once they cross species. Once they leave and enter a species that is not its original host, now it can burn hot and fast. For example, the HIV virus, we see that a lot with these flu viruses as well, where they're not harmful in their original host. So again, if the exogenous retroviruses originated from various hosts in the animal kingdom, and now they've crossed from different species, basically they've still originated from a host cell. But
yes,
then your
but the location will be different when they make that species transition.
But
the
crossing
SIV is located.
But I just want to
in
make
a different
they're
place.
crossing as an exogenous retrovirus, right?
Yeah.
Okay.
Yeah, of course.
Okay.
I mean, it's a horizontal transmission. It has to be exogenous.
Okay.
Well,
Okay. Praise, go ahead. Go ahead.
Yeah, I think what I'm going to do is get the conversation directed back at Ken here. And I have a little clip here by Richard Dawkins. I would like maybe Ken to respond to it, and then maybe if Mark wanted to join in or something, or any other atheist or evolutionist to defend that it's a fact. So I'll let you guys see the little clip here, and we'll see if Mark agrees with it. So here we go.
The word theory can be used to mean something speculative and tentative. In everyday speech, it probably usually is used in that sense. Scientists very often use it in a much more positive sense. I think the easiest way is to use the ordinary language word fact. In the ordinary language sense of the word fact, evolution is a fact. The evidence that makes it a fact is partly fossil evidence, partly comparative evidence, looking at modern species and comparing their bones, their organs, their structures generally, and especially their molecules, their genes at a molecular level. This is extremely persuasive and powerful evidence. You compare the genes of animals and plants, you find that the pattern of resemblance is a tree, a branching tree, and that branching tree could only be a family tree. Other very persuasive evidence is the geographical distribution of animals and plants on islands and continents. They are exactly where we should expect them to be if evolution were a fact.
So we even heard from Richard Dawkins. He said is a fact, and I think he's overstepping his bounds in science, because we could only verify things that are tenable. Or tentative, So things that are tentative could never be a fact, because facts are a priori true. So it's a posteriori true, which means only for the moment, but not in the future. Would you agree with that, Mark? So would you say that is okay?
No. Yeah, so it depends on what you're talking about when you're talking about evolution, because if you're sort of, Kent has this thing where he goes off on evolution is all of these different things. He's talking about biological evolution specifically, which is what most people are talking about when they say evolution. They're not talking about stellar evolution or whatever else Kent's going on about. They're talking about biological evolution. So evolution is simply the change in heritable characteristics over time. That's a simple enough definition for you, right? So just the change in heritable characteristics. So, I inherited probably baldness from my mother's side, kind of thing. Just those inheritance of inherited traits. So we see that in dogs. We see that in all kinds of things. We see it all the time. And that's what he's talking about with evolution is a fact. Now, the theory of evolution is the model in which we describe why it happens and how it happens. So, but when you're talking about a theory in science, there's cell theory, there's germ theory, there's a theory of gravity. They're just models to show, to give an explanation of why we know this to be true. But nobody disagrees that we don't see a change in inherited characteristics over time. Like, I don't think anyone would disagree with that.
I would like to get Ken's take on this. And
Ken,
what does he think when someone says that evolution's a fact?
Well, that's why I'm careful when I do my seminar to define the 6 different levels or stages or meanings of the word. What he's just defined is variations within the same kind. Yes, there are variations. Change in heritable traits. I agree. They now have cows that give more milk and cows that have more meat on them, but they're still cows. Mark will never admit this, but yes, there are changes like dogs, but they're limited. They've tried to get bigger dogs and smaller dogs, and they've got them, the size of a Great Dane and down to a Chihuahua. They're never going to get a dog as small as a flea or as big as an elephant, though there are animals as big as an elephant, like an elephant. They're certainly not going to get a dog as big as the solar system. So yes, there are. He will switch the subject rather than say, yes, there are limits. Every farmer on the planet knows there are variations, and they try to capitalize on them. You want wheat that has more grains per head. Well, then you crossbreed those. Pretty soon you get wheat that has, whatever the maximum number of wheat grains is on a head of wheat. But it's still wheat. This is what they do not understand. They choose to deliberately be dumb about this. Evolution is, if it is indeed change in heritable traits, then will you admit they are limited and they have to take a trait that already exists? How did the amoeba, which doesn't have arms, legs, eyes, or ears, how did it get arms, legs, eyes, and ears, and a brain, and a nose, and hair? Amoebas don't have any of those. But see, you want to take a family tree like this and teach the kids this is science. Look, boys and girls, we started like a protozoa.
Are we doing one topic at a time?
From that. Where are the new traits coming from? Protozoa doesn't have feathers. How do you get a bird out of this? You want to muddy the water and say it's change in heritable traits. Okay, what are the inheritable traits of a protozoa that gave it feathers and arms and eyes and legs and wings? They aren't there. That doesn't happen, Mark. It's a religion. And you are a fundamentalist evolutionist. Congratulations.
Well, I think you're really projecting there, Ken. Did you just call me a fundamentalist because I called you a never mind. So variation within the same kind, but you're going to have to provide what a kind is. Like there's no systematic way to define what you're talking about with a kind. We've been over this before, and you don't seem willing to give a clear, definitive explanation of what your kinds are, which I'd like a clear, definitive explanation of the categorization that you're making with kinds so we could examine to see whether it carries any explanatory weight. So you said it's limited. I would agree that the process does follow certain mechanisms. Yeah, it doesn't skip from one thing giving birth to another, which is what you like to sort of conflate and sort of straw man the idea. So how did a protozoa get to feathers kind of thing is what you asked. Very, very slowly. So what you had is unicellularity, then multicellularity, then it basically worked upwards to very, very simple organisms, more complicated organisms over an incredible amount of time until we got to things like scales, right? So protective elements that came up, and then scales turned into feathers. So the answer is very slowly and through a very, very tiny incremental steps over an incredible amount of generations, not just the whole idea of, one thing giving birth to something with feathers. It's just a straw man, and Kent's now got.
Well, let me respond now. They always go back to this. They always go back to this. What is a kind? He avoided the question. Are there limits to the variation? And where's the new information coming from? The protozoa does not have any information at all to make a feather. Adding time doesn't help give it that information. Adding time doesn't help give the protozoa the information to get bigger and become like an elephant or a human. They've got these charts that kids are learning from, and they show the frogs and the birds and the fish and the insects and the humans having a common ancestor. This is propaganda. This isn't science. As far as what is a kind, the Bible says if they can bring forth, they're the same kind. What is a species for that matter? Google definition of species. I've got it here. I had it up earlier. There are all sorts of different meanings. Here we go. What is a species? Let's see. It's biology. Species is a type, a kind, a sort. They use the two Bible words, kind and sort. Kind or sort, type, kind, sort, genus, family, order, breed, race, strain. God said they bring forth after their kind. If they can bring forth, have babies, they're the same kind. The 10 different varieties of crows can probably bring forth babies, and it would be a crow. They bring forth after their kind. 72 species of herons might be interfertile, but they're not interfertile with a turtle or an amoeba. It's common sense 101 to anybody that hasn't been educated away from their common sense to see organism, definition of species, a group of organisms that can reproduce with one another in nature and produce fertile offspring. Do you think the amoeba slowly gained the ability to become a bird and produce birds. The textbooks show that to the kids. And all answer is always add time. That's your pacifier. More time. Give us more time. It'll happen. It doesn't happen. If it takes more time, you're admitting it's not observable and it's not science. Science, where we can observe, study, test, and demonstrate. Show me an amoeba produce a non-amoeba, or a protozoa produce a non-protozoa. Well, it takes too long. Well, then it's not science. It's imagination. It's fairy tale stuff. You guys will never admit it. I got all kinds of definitions from the word species. It fits the biblical kind. They bring forth after their kind. Would you agree that an amoeba and a bird are different kinds of life forms? I think you would agree with that. So why do we put them on a family tree with them connected to a common ancestor? This isn't science. This is religion. You believe the amoeba, the protozoa, turned to a bird, and you're welcome to believe that. But it's not observable, testable, demonstrable science. You need a good definition of science. Science, what we can observe. Evolution is not part of science. It's nothing but a religious belief. Now, we've wasted an hour and a half on this one topic and one caller. Do you have other callers, other topics to discuss, or does he get the whole program? What do you want to do, Donny?
Well,
I'm
can
here for you.
respond before I go? I think that's fair, since you had a lot to say there, Kent. You know, I think it's fair that I respond. And no, it's not a religion. Your religion you brought up on the screen, it's believing in that silly book because you are a fundamentalist religious person on a compound in the back of nowhere. That's exactly what you are. You cannot accept that this is scientifically true, has been absolutely demonstrated scientifically. You just cannot accept that because your entire worldview is based upon this book. The whole idea isn't that, it had the information when it was a protozoa. The whole idea is a single-celled organism then mutated the information for multicellularity. And we've seen that in Chlamydomonas reinhardti, which I know has been brought up to you multiple times because you had an entire debate with Taylor on it. So this whole Kent's straw man building again, basically saying, well, it's got to be a protozoa going to a bird or else I don't believe it. And the whole idea of time, nobody's religiously believing in time. Time's just something that exists. We just take the facts as they come. If evolution's wrong, it's no skin off my nose. I don't really care. I mean, it'd be nice if there was a big God watching out for us, but it is to Kent. If his worldview is wrong, he's devastated. So we don't care. We just follow the facts where they lead. It's Kent with the religion. It's him preaching his religion and his kinds, and it doesn't explain a kind. If eagles are a kind, can all eagles interbreed? No, they can't. To ask for a criteria to how you separate kinds, just the fact that they can breed isn't what Kent keeps to him. We've seen that time and time again where he says that a certain group is all one kind and there's individual species within that group that can't interbreed. So his definition doesn't work. And what about if a donkey and a horse produce a mule? Does that mule then not... The mule can't breed with anything. Is that mule then a different kind? Under Kent's definition, it would be, because it can't breed with anything. His definition makes no sense. And just because he pulls up like a dictionary definition, which is sort of trying to explain how it's used rather than any scientific definition for the word, doesn't help you, Kent. It's obvious that you're reading from just the most convenient dictionary definition to support you. Stop straw manning. That's all you're doing. That's all you're doing.
Okay, let me jump in. Actually, Kent, before you respond, we got a couple more guests. Obviously, somebody's going to have to get the last word here, Mark or Kent. So why don't we allow Kent?
Am I being kicked off? Am I being kicked off? Am I being kicked?
No. I'm just asking you, Kent and Mark. I feel like you guys could go at this all night. Is there anybody who wants to get the last word in before we move to another guest? Or we could, Kent, feel free to respond to what Mark said, and then we'll figure out what
he mentioned. He mentioned that eagles can get to the point where some of the eagles can no longer interbreed. Therefore, they all came from a protozoa. Is that your logic? Because I think it's. And by the way, our mule just had a baby 5 days ago. They can breed occasionally, and they do. Not a donkey, a mule. Right? You saw it up there, 5 days old. Okay, and 2 minutes after it was born, It was standing up looking for the dinner table and knew where to look. And mules and almost all hoofed animals, when they're growing inside the mother, have gloves or socks on. They come off a few days after they're born. If they didn't have that, they'd tear up the inside of the uterus. How did that evolve? How did they learn? Did the mother learn to produce milk before the baby needed the milk, or did the baby need which evolved first? We could go all day just on mules if you'd like, Mark. You believe by faith that a mule came from an amoeba or a protozoa. Nobody, you take an example like eagles becoming now, or squirrels do the same thing in dogs. Chihuahuas and Great Danes. I don't think it can interbreed unless you did it in the laboratory with a mixed egg and sperm. But see, this is so obvious to a kindergartner. That's the same kind. It's a bird. But you think because they're now different species by some man's classification, therefore, that's evidence that those eagles came from a protozoa and are related to a frog. That's your evidence? You don't understand how much faith you have in your religious belief in the dumb religion of evolution. I wish you could see it. Anyway, go ahead.
Yeah, so that's, you know, it's not faith. We've got evidence for it. I've been trying to present it all day. It's not that, like, sort of, so generally mules are sterile, so therefore we all came from a common ancestor. That wasn't the point that I was making. My point is that your definition of kinds is woefully inadequate to give any clear categorization of any biological life. Because your thing is, can they breed? Now, you just acknowledged that most mules can't breed. Generally, they're completely sterile. And there's certain crossbreeds that we get that definitely are sterile, like they just cannot breed. So under your definition, that offspring is no longer the same kind as its parents. And that's the point I was making. And it's why your definition is abjectly useless. It's because it doesn't actually get to categorizing things. We know that there is a much more closer similarity between humans and other apes than humans and horses. And you say that yourself. Like, of course, we're more similar to them. Your entire classification doesn't take that into account. It's like kinds or nothing. It's useless to us. It doesn't show anything. And I've been trying to bring up the evidence for evolution, and you asked my best evidence. You've sort of been sitting sullenly in the background. I mean, I don't know what more to do for you, but it's not a religious beliefs because it is based on evidence. You might, in your sort of religious fervor and your fundamentalism, go, well, I'm going to believe the Bible over the clear and demonstrable evidence that's been presented to me. That's not my problem. I do have evidence, whether you want to believe it or not. And as we move along,
Mark, do you find that evidence to be like compelling?
Excuse me, I'll just finish. And as we move along and find out more and more and more, this evidence is going to get stronger. So I kind of really hope that you're ready for the discoveries that we're going to make, because after hundreds of years, we've not had anything suggesting in any way that evolution is wrong. I'm really sorry. There just hasn't been.
Okay.
So go ahead, Two Natures or whoever wanted to talk.
I was just going to ask you, do you find that evidence like compelling, or do you find it more faith-based?
Yes. No, incredibly compelling. If you actually read about ERVs, chromosome 2 fusion, the hierarchy, the tree of life, the way that DNA falls neatly in it, the fossil record, just everything. And the thing is, it's multiple lines that all point at the same answer. And that's not even to mention the testable predictions, like we predicted to find something and then found it exactly where we're expecting it.
Mark,
and I mean,
do you want to pick another line of evidence?
Can I ask you,
back and forth on?
Would you disagree with Kent when he says things tend to produce after their kind? I mean, you went on complaining about that, but
well, I don't know what a kind is. Like, so the whole idea of kind, I get what you're saying. They kind of produce things that follow their rough kind of grouping kind of thing. Yeah, okay, gotcha. However, there are certain inherited characteristics that are completely different in some creatures. You know, we do have a change in inherited characteristics, and that's just what we observe. I mean, if you had never heard of a dog and you found a pug and a Great Dane in the forest, you would probably think they're two completely different species because they are so dissimilar to one another. We know that they're not, because we know where they came from and we can do DNA analysis and everything. But, you know, those two things, they look very, very different.
Okay, let me jump in. Kent, is there anything you wanted to respond to? I know there's a few things on the table. From my understanding, another evolutionist is going to be joining in about 5 minutes, I'm told. So if you had anything you'd like to respond to Mark currently, let's say allow Kent and Mark to go back and forth for another 5 minutes, and then we'll kind of go from there.
Yeah, my 2 hours is about up.
Too.
Hang on, my 2 hours is about up, and I have to actually work for a living. So I get up early and about done. So I think Mark has demonstrated clearly that he takes by faith that there will be more discoveries. I can guarantee you that our sheep that just got pregnant are going to produce baby sheep. I have a prediction. The sheep will produce sheep. The cows will produce cows. The goats will produce goats. The chickens will produce chickens every time. You don't have to wait hundreds of years to see that prediction come true. Every farmer in the history of the world can tell you that's all that has ever happened. They've always brought forth what anybody would consider the same kind of animal, but you think chickens and sheep and goats and you are related. No, I'm sorry, you are related to the rat. Yeah, sorry, the rat. Okay, and you may be. I'm not. So
yeah.
Please.
So when you mean related, you're conflating sort of like, I wouldn't say I'm related to you, Kent, right? And that's what you're sort of implying, that that's a familial relationship. And that's not the case at all. So, you know, stop being Kent the conflator. Stop mixing up terms. Stop trying to conflate things. When we say related, we mean like through a common ancestry, that we wouldn't say I'm related to that, whatever it is, fill in the blank. Just like I wouldn't say I'm related to you, Kent. Like, because that's not how we're using the word in ordinary conversation. So stop conflating. Yes, we have a common ancestor. We're not related.
Why do you say you're not related if, I mean, isn't this just a...
Are we related? Are we related?
We do have common.
Well, it's a lot
ancestor.
easier for me to believe that we're related than to believe that I'm related to a rat,
Cool.
to be honest.
And why is that?
Can you hear me?
I don't know if I have to explain that.
Well, it's because we have a much similar
we can hear you,
DNA
Universal.
than say us and a rat, for instance. Like our DNA will be a lot more similar and have very little variation among it. But the DNA of a rat and say us compared to the DNA of a protozoa, let's go with Kent's thing, a protozoa, we're going to be much more similar to a rat than a protozoa or a modern amoeba or something like that.
As far as I was trying to say that as far as I know, we have a common ancestor called Adam and Eve, and the DNA proves it. As far as he's being.
How does the DNA prove it?
You can read the news.
Mitochondrial Eve?
You said it.
Yeah, so mitochondrial Eve isn't just one single female kind of thing. It's basically the last female that everybody was related to, even though there was other women around at that time, because we can trace the mitochondria to other females around at the time. Like, just because it goes, we all are related to one person, doesn't mean there weren't any other female people around at that time. You've misunderstood what mitochondrial Eve
actually is. The thing is this, all right. The idea is we started from single cell to multiple cell, but the Earth is so giant that the 2 cell, the 3 cell, and the multiple cell, they would not disappear. They were spread throughout the Earth, the same like you have different different birds in different areas, different sizes, but they came from the same bird. It's the same with the multi-cell. If there was to be one 2-celled or 3-celled creature, they would have survived, because you have superbly giant Earth where even one population destroys the certain area population of single cell becoming 2-cell. The rest of them, they will survive. Either North Pole, equator, anywhere else. So the Earth is giant. All the species that they were intermediate, they would have survived, but since they were none, They did not survive because they were non-existent. So God created them the way they were. They are. There was
I don't get your point. I really don't understand. Yeah, the Earth is big. Yeah,
yes,
I don't
and
nobody's
two-celled creature would
arguing that.
have survived. There is none
Yeah,
in
and also
existence.
I would like to give this back to Ken
Why
because it's going
wouldn't
to
it
get
have
going here in a few
survived?
moments.
Because
I mean, some cells will survive, some will thrive. Like some will lose that evolutionary race and die, and some will
there
live
is no.
because they prey on other ones. I don't understand what that's got to do with anything.
No, I mean,
Right, but
basically
all right,
explains
guys, I'm
that
going to jump
there
in
was
really quick.
there was no two-celled creature, there was no three-celled creature, there were no four-celled creature. Everything was
No.
created the way it was. There was something else that it was scientific back in the time, in the 400 BC.
Well, let me address that. Okay, instead of you just sort of going on.
All right, sorry guys. I mean, this is the schedule that we had ready to go. I would like Ken to respond to some of this stuff before he gets going, and then after that we can continue that conversation. I appreciate you guys coming in, but this is our special. Ken is our special guest tonight. So Ken, would you like to respond to any of that stuff? And also, I have a video for you if you would like to look at that. You would like. I mean, if you want to respond to it, it's up to you. And
Yeah, well,
whatever you
I
want
would
to do,
like to.
yeah.
I would like to respond to a couple things. Mark has clearly demonstrated that it takes lots of time. That's his belief. Every farmer can show you it happen every day. The cows produce cows, the dogs produce dogs. That's what the Bible said would happen, and that would be science. If he wishes to believe otherwise and believe in these family trees, he should admit this family tree stuff is his belief. It's a religion. They teach the kids in school that all life forms, bacteria, fish, humans, all of them have a common ancestor. There is no scientific observable evidence of that. We've never seen a bacteria produce a non-bacteria, and he will change the subject. I am tired. I need to go. My 2 hours is up. But yes, I'd like to see your video. That's why I point out all the time, evolution is a religious belief. You're welcome to believe it, but stop calling it science and stop pretending it's science, and certainly stop making everybody pay to make all the kids learn that it's part of science. These family trees are baloney. They're drawing a bunch of lines on paper. That's all they're doing. They're connecting them. Wow, look at this. Oh, wow, all the animals are connected. No, they're not. They made it up. It's just a bunch of lines on paper. I could draw lines on paper connecting humans to squirt guns and Volkswagens too. Doesn't mean they're related. So let me see your video, and I got to get to bed. Go ahead.
Yeah,
Praise. Before you put the video, Atheist Junior did just join, and I know he's got a specific question for Kent.
Hey, AJ.
Kent and AJ go way back, and so thanks for being here. If you did have a question for Kent or a topic, we do have a few more minutes, and maybe we should get that in before the video you wanted to play. Praise.
Yeah, I can be fast. So I was gonna, I guess, ask a slightly different question because I feel like I know Ken has limited time. I think this question will be it gets more at the heart of what his main arguments sort of boil down to, and that would be that Kent has an exceedingly narrow definition of what science is, and if we had to refer to things as being scientific as only those that were directly testable and directly observable on human lifespans, we've had a pretty short list of sciences that we could talk about. For example, particle physics. Nobody has ever seen particles that are smashing into each other in the Large Hadron Collider, but I think Kent would agree that particle physics is still science, right?
Well, there are different levels of what can be considered provable, testable, demonstrable science. Science, I just Google the word science and copy the definitions. The origin is scientia, Latin, which means knowledge. What do we know? We know cows produce cows. That we know. We do not know cows came from an amoeba or a protozoa. We don't know that. You can believe that, but we don't know that. You know cows make cows. That would be science. Definition of science: systematic enterprise that builds and organizes knowledge in the form of testable explanations and predictions. All the predictions would say cows make cows. Why would I include cows coming from an amoeba under the definition of science? Because we don't know that, even if it's true, even if it happened millions of years ago. it still would not be considered science because it's not observable and testable. Google the definition. Religions attempt to understand, but religion is not science. I agree. And evolution's a religion. It's not science. How would you define science? Just Google it. Science is knowledge. Knowledge attained through study or practice. All the knowledge we have is cows produce cows. There is no knowledge to contradict that. Science refers to a system of acquiring knowledge. Look at it. Go ask any farmer. Have you ever seen your cow come from a non-cow? Ask them. Questioning science is science. Anyway, so science, the knowledge man has accumulated by observation, experimentation, and testing. Evolution is not part of it. Nobody's observed this. Even Mark said, well, you got to wait millions of years and there's more evidence coming. It's coming someday. He's got great faith. He makes a great evangelist for his religion. Boy, just hang in there. It's coming. Show it to me. I think we got a great discussion on endogenous retroviruses. They're not necessarily harmful. It's been known for 15 or 20 years that there's not good evidence for evolution, but he's not going to give it up. And by the way, that all was just discovered in the last 20 or 25 years. They've been teaching this religion of evolution for 160 years. Now they got the newest, latest evidence. Where was the evidence for the last 100 years? It wasn't ERVs. There isn't any. One by one, they get discredited, disproven, like the gill slits on the embryo, proven wrong in 1874, and you guys are still using it as evidence for evolution in your textbooks. I object to that. I'm going to go on long till I die, and my videos are going to go long after I'm dead. Sorry about that. Science is knowledge, things we've gained by observation. We haven't observed an amoeba produce anything but an amoeba. Go ahead.
Okay.
AJ.
So I did Google the definition of science, and science, the reason that we do science, because I consider science to be not only something like a noun, but it's also a process. And on Google, it says that the archaic, outdated definition is knowledge of any kind, because science isn't just about what we already know. The purpose of science is to find out things that we don't know. So there's going to include things in the field of scientific study, which Google says is a systematic study of the structure and behavior of the physical or natural world through observation, experimentation, and the testing of those theories against the evidence obtained. So the purpose of this study is to find out things that we don't know. And observation in a scientific context, in a scientific definition, does not just include things that we can observe in our human lifespans, but the study of the effects of things that happened long before we were here, or before humans were alive and were able to study science. So we can study the effects of processes that happened a long time ago, even if you think that's a few thousand years ago or longer than that. But observation doesn't just mean a human lifespan.
I want to say something, because Kent misrepresented me. You totally misrepresented me, Kent. And I want to say something, because I didn't say that you had to wait X amount of years in order to get evidence. I presented evidence, and I sort of outlined all of the evidence that we have. So you basically saying that, oh, I said we have to wait thousands. No, that's not what I said, and you know it. Don't lie. I presented evidence, and then you basically are saying the fact that I said, hey, I think we'll get more evidence as time goes along, doesn't mean that's the only evidence I'm relying on. And plus, the papers that I showed, they made testable predictions, Kent. They said, well, if we sort of put this virus back and it reactivates, then we know that this endogenous retroviral sequence comes from viruses that were inserted in the genome. Like all of them, they are doing science in this. Just because you are ignorant of what happens in evolutionary biology doesn't mean that they're not doing experimentations in science. Sorry, AJ, it's just I really don't like being misrepresented.
Yeah, I was going to say, I haven't been watching, but I'm sure that what Kent said is not what Mark actually said.
Oh, you're sure? Look at you, AJ.
Yeah, I can be sure.
Yeah. Sure.
Yeah. It's a common thing.
Yeah, the watch.
You've already judged. You've already decided. Now, AJ, you said science is a process. It's a process of gathering knowledge together to come to conclusions. Like why? Why do rocks fall? Wow, Galileo and all these guys said, oh, let's see how fast it falls. You know, what's the distance it falls? Distance is 1/2 GT squared. Depending on what planet you're on, that'll change. Okay. So, yes, I like science, and I taught science 15 years. Evolution is not part of it. You can study all you want. All we've observed is cows make baby cows. That's science. Wonder why? I wonder if we can vary this. Can we get cows that give more milk? Oh, yeah. Can we get cows that give more beef? Can we get cows that can stand the heat better? But we have to take a trait they already have. Tell you what, cows already made milk. The world record last year was 185 pounds of milk in one day, one cow. It could barely walk, but it produced 185 pounds of milk. You can Google it. Now, in the woods, it wouldn't survive. If you turned all the dogs loose in the woods, then most of them wouldn't survive. Nature would select a generic type of dog to survive. The Chihuahuas wouldn't make it one day. The squirrels would eat them, okay?
Why does that matter?
Science is a process. It's a process of
if
using.
They wouldn't be able to survive in nature, Ken. I've always been curious about why you say that. Why does that? Does that mean it's not evolution?
It's true, and it's obvious to anybody with a functioning brain cell.
He's making
Well,
scientific.
because it's artificial selection, not natural selection.
Oh, one at a
Because
time
if you
here.
do artificial selection, it doesn't. You don't necessarily
Donny,
come up with the animal that
Donny,
survives best in nature.
Let's go one at a time, guys. One at a time.
Who's moderating here?
Mark,
And
go ahead.
then AJ said it's a study of things long before we were here. That would be awfully limited. I think we could study architecture of ancient buildings like the pyramids and say, wow, these people were pretty smart. Can we therefore conclude they were partly chimpanzee? Chimpanzees don't build anything like a pyramid. I don't understand where you're trying to change the definition of science so you can somehow sneak evolution in there. Evolution is nothing but a religion. I got to go, Donny. I'm tired. You guys can duke it out. These guys are never going to get it until they die and God explains it to them. But yeah, it's been a long day. So let's do it
Before
again.
you get
I'll do
going,
it
though,
again
Ken, I
next
have this some short to show you vintage you. This is what you said in science. If evolution is true, you can't even trust your own mind.
The concept that a spiritual force cannot have any effect on a material body, well, then I guess you'd have to explain to me things like emotions and love and hatred and envy and jealousy and rationality. I mean, if your brain is just a random collection of chemicals that formed by chance over billions of years, how on earth can you trust your own reasoning processes and the thoughts that you think? Okay, so let somebody else take over.
Amen.
Right? Thank you.
Okay,
thank you.
Ken, thank you for the 2 hours of your time. We'll have to do this
Okay.
again sometime. Definitely a lively, fun one. So, Kent, God bless. Thanks for joining. Get some sleep.
God
I feel God on my fingertips right now.
Wow. Yeah, I wow. If emotions are spiritual now, I don't get that.
You said it. You said it. It is.
Well, there we go.
Really? Can you show that? Can you
It
demonstrate?
is the Holy Spirit. Hey,
Yeah.
you know,
So
I was
demonstrate
born
it.
in a communistic country where we studied everything about evolution. We never studied about God. And I've been through all the evolutional processes. I've learned it all. And when you look into that, what is not presented in supposed science, because it's not a science, but it's just a repetition of certain things, but not all things. You start believing in that what you guys so-called evolution science, which is, but when you look on the side of the reality, you start realizing there is more to life aside of that what evolution represents.
I'm sorry to interrupt. Are we getting to a demonstration of your spiritual emotions?
No, just
anytime
wanted to
soon,
mention
or-
that I came from where you.
Okay, but that's irrelevant
gonna
to a
get-
demonstration of
I
the
think the
spiritual.
point, Mark, was
That's irrelevant.
understand
That's
that
just
if-
that's just
Okay,
a claim
all right.
of
Let
yeah.
me.
So
all right, that's fine.
demonstrate that
Let's
is
talk about
true.
science.
if you
You
if
know-
you're just
No. Let's talk about spirituality and your demonstration, because you said you demonstrated, and then you're going off on this tangent about where you grew up and what
Listen,
you. That's irrelevant.
if you're just a random
Demonstrate
mutated
spiritual emotions.
mutant, then
No,
why
I-
do you trust your?
I just want to, Two Natures, just a second. I just want a demonstration. Universal Doggo said he could demonstrate that emotions are spiritual. I would like the demonstration that he promised, please. Or can you not demonstrate it?
Actually, you felt it, but you just suppress that what
I
you
felt
felt.
it.
You said
yeah.
the spiritual. and you know it is spiritual, but you suppress it, so you don't want to admit.
That's an assertion.
Well, no,
That's
universal.
not a
Okay,
demonstration.
all
That's an assertion.
Universal.
There- okay,
Mark, Reid,
Guys,
Mark,
guys, there's a little bit of overtalk, please.
let's
get to what
quickly
we've been
let's
doing one at a
briefly say
time.
about science. We talk about the Bible and science. The Bible
No
states that
demonstration. Okay.
the globe of the earth hangs upon nothing. And if you read the beginning of Genesis, it says the firmament where the birds fly. There was water above the firmament where the birds fly. All right, the theory of yeah, the ice cover above the
Canopy.
air.
Canopy theory.
Okay, yeah, but you know that not too long ago they found a mammoth plus the little one, I believe what's called Dimitri or something like that. But what was the significant thing of that mammoth besides that it was standing frozen with the food inside the mouth? If you read carefully, they
I
talk
don't get
about
the point of any
those
of this. This is
thick
just
bones.
a long
Okay.
monologue.
Yeah, guys,
what are we
I'd like to
talking
keep.
about
I'm
here?
going to jump in. I'd like to keep it as free flowing as possible.
Just wanted to mention that the bones they were.
Please, I'm talking.
Sorry, my
I
bad.
want to keep it as free flowing as possible, on topic as much as possible, which is evolution. And so maybe
Right.
there's something we want to engage there. Mark, if there's anything you'd like to respond from Universal Doggos, is that your name? Universal Doggos?
The kids
okay.
they use
Fantastic. So
they use my channel, so they named it Universal Dogs.
No worries, good to have you.
I never changed it, so I like it.
Yeah. So Universal Doggos, there's nothing to suggest that emotions are in some way spiritual. You've made assertions, and the difference between an assertion and a demonstration is that with a demonstration you can actually give some sort of evidence, i.e. that which is evident to back up your assertion. So when you sort of say, hey, yes, I can demonstrate that emotions are spiritual, I would expect some demonstration that is the case. Now, as it turns out, we can actually read emotions like under MRI and from neural scanning to see how our brain chemistry is reacting. And as far as we know, there's no spiritual component to it. All of it's very well understood. Things like anger, fear, love, jealousy, all of this is very well understood and explained perfectly well with cognitive states of mind rather than some kind of spiritual thing that's doing it. Now, I can't demonstrate it's not something spiritual because I don't have access to a spiritual world, but I don't think you do either. And in order for me to believe you that it is spiritual, you're going to have to make some sort of demonstration, not just assertion, not just claim it, but some sort of demonstration that it is in fact a spiritual thing.
Doggos, you can do that. I just
Actually,
don't think you know how to do
it's
that.
being
Hey,
done many
Bubblegum,
times.
I'm going to jump in. I want to make sure Doggos now has a chance to
I
respond.
just wanted to say
Bubblegum,
that,
we will circle to you. Don't worry. We'll circle back to you.
if
Go ahead, Doggos.
if that is been demonstrated many times, just it's apparently it's personal because aside of Jesus Christ that everybody knows exists, including all the atheists, they have proven it because there are over, I think, 60 documents that they prove the existence of Christ. Aside of that,
60.
I think recently I watched a documentary that the guy was saying that including in the papacy, there were many documents that if you read them, it was the guy was actually he was charged by CIA. He was operative. He was absolutely agnostic and actually close to atheist. He was assigned to prove that there is no existence of Christ. And actually, when he was allowed to get into the papacy, he found so much information that he said it's almost criminal for the papacy to hide all these documents. And since then,
are we getting into CIA conspiracies?
Yeah, I
now?
don't.
No, it's not
I
conspiracy.
wanted to
He
say
talks
something.
openly. He tells his name.
This has nothing to do with anything.
Okay,
Come on.
all
now.
right.
Okay, guys, let's get back to evolution. So,
All right,
is there a specific line of evidence or anything that let's say
I
Mark
wanted to
bring
say
up,
something.
I
real
have
quick.
some. Oh, go AJ. Yeah,
Let's
go.
talk about science quickly. science
Well,
quickly.
a while ago, you said that you've been studying evolution and you've learned it all. Like I would say that I've learned about
always difficult
evolution
to say
a
because
little
that
bit,
was
but I
many
would
years
never
ago.
say that I've learned it all. I would think that's a bit arrogant.
Let me ask something to
All
Mark
basics,
and,
okay. All
and
basics.
AJ. Would you agree that it like I know this is not the way you want me to word it, but would you agree that it's pretty hard to believe in evolution? Like it's not so clear cut as
I
say
think
other
it's
science.
hard to comprehend it because
Is
it's
is that
very
addressed to me or?
No,
I
to
think he
Mark
addressed it to
and
me.
Okay, I'm sorry.
AJ.
I think it's hard. It's a difficult subject to understand and comprehend completely because it's a very it's a scientific field with a lot of interlinking disciplines, and it is hard to understand. It's hard for a lot of people to accept. I wouldn't say believe, but a lot of people don't like the idea of being related to animals, or specifically like monkeys. Like I didn't come from no monkey.
No, I don't mean like that. I mean like I'm trying to ask if it's hard to because to me the evidence I don't find it compelling.
Okay.
And
Well, I think I know what you're asking, and what I would say is yes, part of it is unintuitive, right? So, like a lot of scientific disciplines, there are things that are unintuitive. It seems like to our sort of common sense that it wouldn't make sense, kind of thing. Like the way that gravity causes objects to drop at exactly the same rate, no matter what the mass of the object. That's unintuitive. It doesn't seem like it should be the case. But as it turns out, the way that gravity works, that is exactly the case. So yeah, I can understand why it is hard to wrap your head around, because some of the concepts in it are kind of really unintuitive. Like they don't, until you actually learn the details behind them, and then like gravity, it makes total sense once you actually learn the forces at work that cause two things, no matter how big they are, no matter how much mass, to drop at the same rate.
Do you remember earlier I was mentioning the size of the Earth? Basically, the Earth is really, really big. If there were different animals, they would have survived in different places. So
Which they have.
any transitional animals, they would have survived too, especially in the oceans that they're so immensely giant, but they are known to be found. So it's very difficult to say that they were
That's a claim.
So you don't.
It is a claim that it is truthful. It's a scientific. You can look into the animals, and you cannot find anything transitional between one and another.
Would you say that the evidence is so solid?
Mud skipper.
Just be honest with me. Like I want you to be as honest as possible. Not just for the crowd. I'm just saying, like, be as honest as you can. Would you say that you could be a scientist but still not believe in, the typical evolutionary model?
Yeah, you could be. I mean, anyone can be a scientist.
Right. But would you consider them scientific? I guess, because I know a lot of people mock people like Kent Hovind, and they mock and they scoff. But what a lot of what he's saying is science. You got to at least admit that much, right? Like
I will not admit that.
No.
What I'm
a lot
saying,
of what he's saying
listen.
isn't science.
What I'm saying is this.
Isn't.
Listen, that he's not wrong to say that cows produce cows. Would you say?
It's true.
Evolution says that as well. Well, let me answer, Universal Doggos. That's what evolution says as well. There's a law of monophyly, which says that you can't escape your previous clades. So, for instance, we are all still vertebrates. We are all still mammals. We are all still, all of these things. We haven't left that clade that we have.
Are we still fish, Mark? Are we still fish?
In a certain sense, yeah, but there's no such thing as well, Bubbles, if you let me finish. There's no such thing as just fish. Okay, that isn't a thing.
Well, so,
but there's ray-finned fish, there's lobe-finned fish, there's a whole bunch of different types of
but neither is vertebrate.
Actually, let me ask a question, Bubba. But I want to ask a question. Mark, what about the step from invertebrate to vertebrate? what kind of jump was that, and how does that relate to the law of monophyly? If you could speak.
So
to
it probably it came by the way of cartilage. So like some animals still keep a cartilaginous skeleton, like sharks, for instance, right? So they don't have a bony skeleton like the bony fish developed, kind of thing. So it was probably the step from a nervous structure to cartilaginous, that's a hard word to say, cartilaginous tissue to, calcium bone, basically.
Cartilaginous. And if I could just piggyback on what Mark
Cartilaginous.
said.
You guys are just making up words. Because look,
that's a made up word. Okay, so I just wanted to respond to Donny real quick.
Look, but what I mean by that, what I mean by that is you guys are just making up these categories.
I want to just respond with another question because I find this interesting. So let's say we have, would it be jawless fish basically that would have roamed the oceans millions of years ago that evolved into most vertebrates? Mark, would you say?
I don't know.
Can I quickly just mention?
I'm sorry, Donny. I can look it up. Maybe I can find it.
Just to mention.
Because I'm wondering when Doggos, please.
Okay.
When,
sorry.
Because I'm trying to have a discussion on the law of monophyly.
Okay.
So from invertebrates to vertebrates, let's say it's some kind of fish in the oceans that is the precursor. As it applies to the law of monophyly, when you get populations of invertebrates evolving into populations of vertebrates, what there is in line with the law of monophyly? Like, what do those vertebrates remain as? Because obviously they're vertebrates now as compared to invertebrates. So if they've evolved from invertebrate for fish, are you saying, well, they're still at least in the fish category, or like what would they still be considered?
That's not how we classified previous to vertebrates, kind of thing. So we don't classify things by what they don't have. We classify them by the features they do have, right? So we don't sort of say, hey, there's a non-mammal sort of classification. No, that's not what we do. We say, hey, we are mammals because we suckle our young, kind of thing. That's how we classify everything.
Okay. So basically, and I appreciate that answer. If I could clarify, so basically, an invertebrate being a cold-blooded animal with no backbone. Now we have a vertebrate with a backbone. So if we go with descent with modification, it's basically the same thing as its ancestors were, but it's now adding more traits. In this circumstance, a vertebrate, and so now it's basically adding to the classification scheme because of its new traits. So now it's a vertebrate, basically. Where before it wasn't.
Yeah, the tree splits at that point.
Let me ask you something, Mark. You said something.
Yeah, and it
that
was
I found
jawless. Sorry, teenagers. I'll just interject. Yeah, it was jawless fish. So there's a couple of a genera of Hachiorchothysis. It's sort of it's basically elongated skull jawless fish, and it had a primitive notochord. It's a flexible rod that isn't actually a spine, but really just a sort of primitive cartilage covered by fibrous sort of stuff. I can. Wow, that's
now
hard to say.
In your opinion, have we seen? And I appreciate that, Mark. So jawless fish, invertebrates, no backbone. In your opinion, have we seen this type of novel change or jump in the animal kingdom today, whether in a lab or real time? Have you, in your opinion, do you think we've seen that type of novel change in phenotype?
Yeah, I think the movement, well, in phenotype, I really think that Chlamydomonas was a huge jump. And AJ knows all about that one. You know, the single cell to multi-cell is a huge step. So I think that is probably you would have to say, hey, that is a different sort of classification.
It's as significant, I would think.
Right.
Okay, so you would argue, and that is an answer to my question. I appreciate it. You would argue that jump or change basically from invertebrate jawless fish to vertebrates, where these fish or creatures now have a backbone, that is of the same significance, AJ, as what we see in the Chlamydomonas?
Yeah, and I think that because I think that Chlamydomonas, that what happened in the lab is not something that's necessarily happening in nature. Like, but that jump, that experiment, I think reflects what happened in early evolution from going from single cell to multicellular, which was a really huge change because in the example of the algae, it was getting eaten. The single cell algae was getting eaten by a filter feeding predator. And once it was able to become multicellular, it was now too big to be eaten. So, and it had because it had an extracellular matrix, which is, you know, I don't know if it's a mutation, but it's a beneficial change, and it was able to specifically survive better because of this change. So I think it is, and there's probably advantages to having a backbone as well. I'm sure, being chordates.
Well, something I will say. Can I just add something really quickly?
Sure.
The change from like having a no backbone whatsoever to having a backbone is a lot slower, like more gradual progression than what we saw in the lab with the algae, because what they're talking about is sort of a very, very primitive notochord, like it's basically barely a backbone, just fibrous material that slowly developed into a backbone. So I think that jump that we've seen is actually more significant because it occurred in like, how many generations? Was it like 100 generations or something? It wasn't a lot.
Well, and that's what I was going to ask, Mark, and then specifically AJ, is in the lab with these Chlamydomonas, these amoeba species, how many generations? So if you're saying about 100, how many generations? Algae.
It was over 50 weeks.
Okay, so 50 weeks. Now, is it true, AJ or Mark, if you know, that this Chlamydomonas from single cell to multi-cell, basically the Chlamydomonas was able to, the one group was able to go into this multi-celled like state, but it was also in the presence of a predator, but it was also able to go back to its pre-existing state. So basically it had the ability to go from one state to the other. And another group of algae in a different study or different paper, they went into that multi-celled like state in the presence of a predator, but they were hit with a certain mutation that kept them in that state. And so now they're not able to go to and fro between the states. Now they're stuck in that state. Is that true? Or speak to that a little bit, gentlemen.
I've only read about the one that had the mutation that stayed in the multicellular state. There may well have been. I don't know. Do you know, AJ?
No, I hadn't read about one being able to go back. I don't know about that.
Yeah, well, one was able to, from my understanding, go to and fro basically from these states, from living in the single cell like state, but once introduced to a predator, they're able to cluster together, and in the presence of that predator, adapt. But once that predator is removed, it can go back to its previous state. Well, one group went to that multi-celled like state in the presence of a predator in relation to some form of adaptation, but they are hit with a certain mutation or something in the genome. They're still studying the genotypic effects of this that kept it in that state. So I'm wondering, because this adaptation occurred in such a short amount of time, was it 50 cycles you said, or 50 weeks you said?
Yeah, it was 50 weeks. I'd have to look up what the generation time of algae is, but it was certainly a short time span.
So I'm wondering if there is a pre-existing ability for these organisms, this algae species, to basically have a type of multifunctionality where in the presence of a predator, they could go into this multi-celled state. Once the predator is removed, they shift back to their pre-existing state. But with one group, possibly they were hit with something in the genome that's now keeping them permanently in that state, which means they've lost that multifunctionality. Now, I think there's still some study that needs to go into this because we don't know every detail about what's going on the genotype of this Chlamydomonas. So I'm suspecting this could be the case. Go ahead.
Well, I don't think so, because there were plenty of Chlamydomonas that just got eaten. You know, they just got eaten wholesale. The predator just took them out, kind of thing.
Right. Oh, yeah.
And that's sort of, you know, if it had that ability, then already as the original algae species, then you would expect them to employ it to, as a survival mechanism, which all organisms do, to try and survive that predator. But the fact that it didn't, sort of says that they didn't have that ability.
Can I speak on that mutation?
Well, let me just say one thing. I think just with any species like humans or, great ape species, you'd say non-human apes, algae, obviously, certain fish species, we as groups have the ability to adapt to a number of environments. But individually, some of us are better at adapting than others. And so that seems to be the case with these algae species, where some individuals were able to cluster together and adapt. Others, although that potential is there, they weren't able to manifest it as successfully as other individuals. And so they were eaten, they were killed off. So that might be the case too. It's curious to me because this adaptation was observed in only 50 weeks, or relatively a few generations, especially compared to going from invertebrates to vertebrates. And so I suspect it could be a pre-existing ability because of that short time frame. This manifested, because if it was true multicellularity, I feel like it would have been many more generations than what was actually observed, because that is quite a novel change. That's a big jump. Anyways, go ahead.
Okay, can I speak on it? What happened was that, yes, they had a pre-existing. It's not a gene thing. It's a behavioral thing. So they're just acting in a colony to fend against this predator. But what happened is that they became immotile. That means they can no longer move, and thus they can no longer separate. So no shit, Sherlock, they can't separate. And so now the atheists want to, and so now the atheists want to claim, whoa, look at that, multi-cell evolution. No, they can't move. That means they can't separate. You big brain. Oh.
But bubblegum, keep it PG-13 because we do have, it's a Christian audience with some kids.
My bad.
So 10 children are listening. My 10 children are listening.
Well, I think children are talking as well. Plants can't move either. It's not. You can't look at it and go, oh, well, it's.
But the difference here is
bubbles. Hold it. Let me speak. So you can't just look at it and go, oh, it's immobile. It's obviously not a good survival strategy. No, actually, being multicellular and still unable to move is the best survival strategy for that time, because the ones that did form multicellular groups, even though they didn't move, they were too big for the predator to eat them. They couldn't actually be killed.
Here's the problem.
As long as it's a survival, hang on, let me finish. As long as it is a survival strategy, not moving doesn't factor into it. It doesn't matter as long as they survive. That's it.
Here's the problem, Mark. I'm going to play that logic. I'm very safe in my house. I don't have to go outside, and I'll be away from the gang violence. Guess what? If I don't leave my house, get food, I still die.
What's the significance?
Are you an algae? Do you photosynthesize?
Do you think algae don't require other resources besides sunlight?
Do you grow your own food? Can you grow your own food?
Do you not think they require water?
Do you require air?
Solution being.
If the Uber brings me food, somebody brings me food, I can stay in my house, but I have to work for it.
What's the significance of the multicellular thing anyway? Like, why does it matter?
Because they're claiming it's a multi-cell evolution. It's not. It's just simply it's a cell becoming a crippled, and they're like, look at this crippled, and now they get a bunch of cripples. They can't move together, so you got a bunch of cripples, and now they're claiming, look, it's a multi-cripple evolution of multi-cripples into one major cripple.
So that's just destroyed by bubbles. So the thing is, the significance is that you have a single-celled organism and a multicellular organism is a huge step. In an evolutionary context, kind of thing. It's a massive step, like to have single-celled organisms and then have a true multicellular organism that all the cells rely on one another. What it demonstrates is the likely scenario of predators causing cells to band together, and then you have a symbiotic relationship. Like we know, for instance, that the mitochondria has a totally different DNA than we do, right? It's like a foreign body in our cells. So it kind of goes to explain how the symbiotic relationship between the mitochondria and the normal cell that we have sort of evolved together.
Here's the thing. When
Actually, no, Bubblegum, I want to respond. Because there's been a couple things, and then you can go after.
Sure.
See, I still think it's curious, and there is still a lot of research that needs to go into this. The authors of these papers admit that there's still a lot in terms of the genetics of these changes that need to be worked out. What's really going on the genotype in detail, and so I suspect that these clumping traits that we're observing in the Chlamydomonas, in these algae species, could have pre-existed simply because of how short it was for these adaptations to come about, and because we have at least one species of the algae that is able to go back and forth between clumping, right, express this clumping ability, and then free living. I think the one species, a possible case is that they were hit with some kind of mutation that kept them stuck in the clumping state. And therefore, it would be, in a way, a loss of specificity or a loss of their previous ability to multifunctionality, basically going from multifunctionality to now just that one function where they're stuck in the clumping. It seems like it would be better to be able to go to clumping, but then back to free living, depending
on the environment. That depends on the environment.
It's not better
Doc.
if you die.
I believe they were put
Yeah.
in an aggressive environment, and what happened is one cell surrounded itself with the rest of the cells to protect the cell from the aggressive environment, or the liquid that they put it in. And basically, you're surrounding yourself with dead bodies of your buddies, so when somebody's shooting at you, you don't get shot. Basically, pretty much that's what happened. That's why they clump together, or that's why.
No, they weren't dead. They weren't dead. Don't
No,
be
no,
silly.
no.
They were all alive algae cells. No. Don't misrepresent the study. All the algae was alive. It even budded off new pieces of cell. And I do see there's a question for me in Study God's Word. How did the first cell duplicate? Mitosis.
Here's the thing.
Mitosis.
Here's the thing. When atheists say beneficial, they don't mean healthy. So they can say something is beneficial without completely being healthy. For example, they would say cancer can be beneficial because you might get some prize for it, but it's not healthy.
What? I've never heard that.
You literally,
guys, hey, let's stick to this algae topic, and then we'll move on to another thing.
Can I jump in here on the?
It's on the topic of algae.
Hey, let's try and do this. If a creationist makes a response, let's make sure that the next responder is an evolutionist. So let me say something, and then we'll allow either Mark or Atheist Junior to respond. So again, if these algae species, let's say Chlamydomonas, for example, if they are expressing this trait, and now they're able to clump together in response to this environment and this predator, well, the fact that they're expressing a trait tells me that this trait pre-existed, because it's a pre-existing gene or ability that's now being manifested or expressed. It's an adaptive episode. But if another group, basically that expression is hit negatively with a mutation, now they're stuck in that clumping state. And again, I would argue this is most likely the case. More study needs to be put into it, because it was only 50 weeks or a few generations for this expression to be manifested. If it was truly an example of a novelty, then I would argue that it should take long. It takes a long time for these kinds of beneficial mutations to accumulate and then become manifested in the way that we see here. Okay, Mark or AJ, take your time. Respond if you'd like.
You'd like to go, AJ?
Yeah. Do you have a link to the something that talks about them being able to go back and forth? Because I'd be interested in looking at that. And a second ago, I mean, I'm wondering why you describe them as being stuck in a clumping stage, because to me it seems like whatever advantages they might have had as in a single cell form, I think it's negated if being multicellular means the difference between living and dying, which whatever advantages they had, it doesn't matter if they get eaten. So I would say that in evolution, the the thing that is the most valuable is whatever increases your survival advantage, which is caused by a selection pressure, not necessarily traits.
Well, because I would argue if a certain organism has built-in multifunctionality, kind of like how GM builds its cars with both a heater and an air conditioner. And so if you're driving your car in an environment that's really hot, you can put on your air conditioner. If you're driving in Alaska, well, you're probably not going to use your air conditioner. You're going to use your heater. And so that's a benefit. But if somehow you're driving in Alaska for an extended period of time and your air conditioner breaks down and now you're only stuck in a vehicle that only has the ability to have its heater, well, that's nice, but it has reduced overall in functionality, because now if you go into an environment that is really, really hot, then you're going to wish, man, I wish I had that air conditioner, right? But it's broken. And so these species of algae perhaps have that ability for multifunctionality. Okay. And so one group is able to go to and fro, and I can get the paper and details on that. I don't have it in front of me, but
Sure.
It's what I remember reading.
Right,
and so this algae is able to clump together, right? So this clumping trait is expressed. And once the predator is removed, they're able to go back to that single celled leg state. But then another group is permanently, for whatever reason, whatever's going on in the genotype, maybe some type of deleterious mutation, that expression is there permanently, where now it's stuck in that clumping state. And so overall, yes, it's good because it's adapted to that environment, but there could be a negative side effect where other alternative environments, it'll be worse off in, because now it's really only has that one added. Go ahead. I said a lot there. Go ahead.
Yeah, Donny, everything's a trade-off. So yeah, maybe sort of that flexibility in your environment would be an advantage. Sure. Sometimes it might be. Maybe if individuals are separating from a colony system rather than a multicellular system, that they might get picked off. The multicellular system may not need flagella to move because it doesn't move. That may be an advantage as far as like where you put resources into. It may be other benefits, like the way that the cells interact with one another in a multicellular one, in as opposed to a colony system kind of thing. There's other trade-offs that may be beneficial. I don't think we can sort of go under all circumstances. Flexibility is the best option, because flexibility to maintain, for instance, cell walls and flagella and all of these different systems to enable individual autonomy, that takes a resource cost in having to grow all that stuff, that it might be advantageous for the one that has less flexibility. But that
can I jump in here for a second?
Yeah, I want to say one thing, and then I don't want to hog the mic. I'll allow a couple of the other creationists, intelligent design advocates to jump in. And so I appreciate those points, Mark. And I'm not saying it's the case in all of the animal kingdom that what we have is flexibility among these creatures in terms of what we're observing, right? These adaptive episodes. But I am suspecting, again, I've said this a few times, so I don't want to sound redundant. I'm suspecting this is the case. And again, more study needs to be looked into this with the Chlamydomonas and these algae species, because of the fact that this clumping trait, this adaptive episode, it manifests. It's been observed in such a short amount of time. You'd expect these kinds of beneficial mutations accumulating over time, this kind of novel change that is as significant as your change from invertebrates that we were talking about a while ago to vertebrates. You would expect this to take a little longer than just a few generations. And so it could indeed be the case that we're looking at organisms that have multifunctionality. And I'm not saying that
750 generations. Yeah. And very rapidly breeding.
It's 10 to 14 hours is the generation time for.
And these single-celled organisms have shorter generation times.
Oh, of course, yeah, absolutely.
Yeah. Right. Right. And so, again, if it's built in, it's still significant, right? But it wouldn't be the type of change that I would argue is necessary to take your fish to fisherman, that kind of large scale evolution. And Mark, you talked about a trade-off. And so I agree. Trade-off is significant when it comes to adaptation. But I think the question is, and we could have a whole debate on this, is that trade-off sustainable? if all we ever really see is trade-offs in the animal kingdom when it comes to these adaptive episodes, is that trade-off sustainable? And I think that's where the debate is really going to take place. Mark, you and I could probably talk about that question for hours.
Yeah. And that's a fascinating question. What is a good trade-off? Is a bigger brain necessarily good? That's one of the ones that sort of, you know, trip up the evolution scientists, because it's like, well, when did a bigger brain start to become an advantage? Because on the surface level, it may not be that big an advantage compared to, say, a lot of muscle or being big and strong like a gorilla kind of thing. You're probably going to do better with just raw strength. But obviously, at a point, a bigger brain made a huge difference. It does in chimps as well. Chimps have amazing brains. They're better than us at some things. Yeah, well, chimps have a better short-term memory. You should look up short-term memory in chimps. It's absolutely amazing. They can, like, you know, the number sequences, they can do those flawlessly. Like, it's insane how good this short-term memory is.
I've seen videos of that.
Oh, it's incredible.
Well,
but yeah,
I want to ask a question on this Chlamydomonas. What was the predators that they put in there? Because when I read the papers, the only thing I could find was that they were using a centrifuge to spin them in a high rate of speed, which then caused them to clump, and then after several hours, they went back to their single cell. So what kind of predator is a centrifuge? Where's that found in nature?
It was a filter-feeding protist.
Yeah, it was a rotifer called Brachionis.
No, it was it was talking about a centrifuge which was spun for several hours, and then they were taken out, and it went back to its original state after several hours. Because I read the papers too, the ones that Taylor and Jamie from Studio 215 were using. And I don't remember them saying anything about a specific predator. They just used the word predator, but they were talking about a centrifuge.
Well, I'm looking at the paper right now.
No, it's a smaller bacteria that eats them. So they clump together, but they do afterwards they split up. So
I'm looking at the paper right now, and it said that they were putting a centrifuge to make the cell membranes more permeable to a staining solution so that they could more easily see the algae. I haven't seen anything about.
Okay. So again, they were putting a centrifuge in order to do this.
Yeah.
Sure.
So what?
So if it was a centrifuge that spins these things around in order to make them, what predator were they talking about? Because when I read the papers, I didn't see anything about a predator. They kept using the word predator, but they didn't define it. They didn't describe it. They didn't say what this predator was.
It was a smaller bacteria that is, but they declump afterwards. Basically, they are not permanent. They just clump together for a little while, and afterwards they declump.
After they took them out of the centrifuge, they were clumped together for a couple hours, and then after a couple hours, they went back to single cell.
So they never.
I have not been able to find anything that says that in this paper.
Yeah, I can't find that either. I mean, I'm looking at the paper right now, and they said that they.
Well, the one I was looking at was.
Hang on a second. Hang on. Like, just don't talk. Hey! Just don't talk over the top of people. Like, seriously. So
you mean like you did?
It's all right. It's okay. Let's hear what he said.
Yeah. So they use a centrifuge to mix up the algae with the like the growth medium as well as the testing medium, so they could, as AJ said, so they could tell what happened. But they point out the exact. I mean, I can copy it into the text. They point out the exact species of what they used as the predator. So that is the name of it. And the thing is, it's a scientific paper. They're not going to say in layman's terms what this thing is. They're just going to give you the species name of it. Right, but you can look that up. It's on, you can find out what it is.
But probably they didn't mention that they declumped afterwards. Means it took hours, but yes, they detached from one another.
Yeah, absolutely.
So it wasn't a
paper,
permanent.
And it was a 2000. I believe it was a 2013 paper that one and the one that Taylor was using. I looked at both of them.
Well, this is 2019, so I'm not sure what paper you're talking about. Maybe you need to pop it in the chat or something.
Well, I'd have to look it up again. It was a couple of months when I read through it when this topic first came up.
I have a question to moderator.
Yeah.
Do you want to make like a series of something called the Bible?
A series titled The Bible?
Yes, and talk about scientific facts and future predictions and etc. Including the ones that they are non-believers, evolutionists. They can join. Basically, many of them, they have a lot of information that could fit in as a puzzle into recreation of what the Bible says about science and even future predictions. Like
yeah, if you do go to my channel, this is not my main channel. This is Praise AM's channel. So if you do go to my channel, Standing for Truth, you'll find a variety of series and videos addressing those topics. So very good, very good. Now I would like to say, because I personally have about 35 minutes left until I am going to go have dinner and relax a bit, hang out with the wife. So if we wanted to shift the topic, I don't know, Mark, I enjoyed your discussion with Kent, and I know you both you brought up a few points, ERVs. We had a good back and forth on that, Mark.
Well, if you don't mind, I actually have a question for Praise. Like, you basically got a thing in there saying evolution is racist. I don't understand why that would be the case. Like, what makes you think that?
Praise, you're on mute if you wanted to interact with Mark's question a little bit.
He might have stepped away or something like that. I don't know.
I'm here. I'm here. Yeah, I heard the question. So the reason why I say it's racist is because of Darwin himself. So in his book, he was saying that the white ape is more evolved than the black ape, and that's actually the words from his mouth. So that is racist.
I don't think that's what he said. I mean, he was an abolitionist, and when he said races in his book, he's talking about species, not races of humans. You know that, right?
No, he is talking about like black and white people. He does talk about races.
No, he's not.
Yeah,
he does.
No, he's not.
He does.
Well, the title of the
let me
book
ask
is
you,
Most
Mark.
Favored Races.
Mark, why does it matter to you if he was racist? Because wouldn't there be no really objective, right and wrong in your worldview? Or
yeah, no, it basically it doesn't really matter. He was a sort of a person of his time, where everybody during that time thought that the white race was superior. That's 1800s or so, I believe it was. So it wouldn't be surprising at all, kind of thing. But I think for his time, he was sort of pretty progressive. He was an abolitionist. He wanted to abolish slavery. His entire family had been for ages. He kind of thought that the white people were superior, but everybody did at the time. It doesn't really matter. It doesn't mean that evolution is racist, because we don't even use Darwinian evolution anymore. We're onto integrated synthesis now.
Well, I would say according to Mark Reid that we all are still technically black people, since according to them we came from like some sort of African population. So
that's a
I should still be able to use the N-word according to Mark.
Yeah, so that's a total straw man and just makes about as much sense as Bubbles usually
Well, you
does.
do believe
there's nothing that
we don't leave our genus, according to you.
Yeah, I did not say that in the slides.
No, evolutionary theory says we do not leave our genus. So you do accept that.
So as far as racial stuff, I'm kind of hesitant to get into racial stuff because there's no genetic differences. There's so little genetic differences between the different races of humans. Like it's almost negligible. We're all the same species, all the same subspecies. There's no difference between us, sort of genetically speaking. Now, when the different races did split, it doesn't mean that like white people came from black people. It's just we had common ancestor. Of course, Bubbles, refuses to understand this because it's Bubbles' usual thing of making really weird statements. But
Mark,
I never said that in the slightest. Yeah, so Bubbles, I didn't say that in the slightest. You're just misrepresenting me as you usually do. You have nothing valuable to add at all.
That is the evolutionary theory. Like,
Look, Bubbles,
main
quit
story.
trolling. Go somebody somewhere else and troll. We're trying to have a
No, actually,
reasonable
actually,
conversation.
That is
partially right.
evolutionary theory. That
I
is
think
That is not.
consensus. That is consensus.
No,
Wait,
it's not.
you're saying we didn't come from like an African
Bubbles, we're
population?
trying to have a decent
What
conversation.
continent? Wait, what
without
continent did
trolling.
humans? What continent did humans come from, Mark Reid? You don't
Asia, Asia.
Asia?
Africa.
Yes.
Okay,
No,
so you do. So you do believe we're still
no,
some
we
sort
came
of
from
land-
Asia. We were medium dark, like Arabs.
Well,
No,
but actually,
according to
they were
evolution-
genes.
all the
I'll go,
people in
according to
Africa-
evolutionists.
Yeah,
All right, guys, we're going to
so-
change topics soon. So whoever wants some
Yeah.
final words on this one, I want us to move to a few topics that were brought up during the main 2 hours. ERVs was great, Mark. We had fun. We'll do that again. I would like us to interact a little bit on the fusion too. I think that's
Yeah.
I think the two best lines of evidence for evolution would be ERVs and the chromosome 2 fusion. And so,
well, Grayson just joined, so if there's anything Grayson wants to bring up, as the new guy in the room.
Yeah, I just
Actually,
really quickly.
Grayson, before you talk, I wanted to say, I knew you couldn't resist, Grayson. You said you're not joining. You're preparing for your 2-verse-1 debate in a couple nights, but I knew it. You can't resist, Grayson. You're like me.
Well, I was listening to it in the background. I really didn't have any interest in another debate with Kent Hovind because we had just talked a couple days ago. But when Centurion was talking about Chlamydomonas and asking about this, I just wanted to point out that I think that he's getting confused because there's multiple Chlamydomonas papers.
Right,
And
there is.
The 2019 paper is the one that goes through. It's literally called De Novo Origins of Multicellularity in Response to Predation. And it very clearly states which predator, the Paramecium tetraurelia, and he's talking about the 2018 paper. So he's talking about a different paper because that's the paper that Snake is Right and Studio 215 were arguing about with the centrifuge. So there's one paper that uses a centrifuge and there's one paper that uses just the predation. And he's confusing the two very separate papers. So he needs to look at the 2019 paper for an answer to his question about which predator was involved.
Okay.
Well, I got the paper. I got the paper. It was evolution of an alternating uni and multicellular life cycle in Chlamydomonas.
Yes, that's the
30 May
wrong-
2018.
Yes.
So
you
that
are
was
talking
that
about
was the
2018.
that was the
talking
original one that I was
Grayson, just let him finish.
referencing.
No,
That was the original one that
okay.
I was referencing. And then
That
if
is-
there's one, what's the one for 2019? I'll look that one up.
It is by
It's in
it's
the
by the
chat.
same main authors, but it's called De Novo Origins of Multicellularity in Response to Predation. That's the paper that you should be looking at because that's the one that you're thinking of where that uses predation. So that's the
Okay.
one that you should be looking at, not the 2018, the 2019.
Okay, I appreciate it, Grayson. Centurion, I appreciate it as well. We've had a good chat on that specific topic, went back and forth. And that's why I was pointing out there's different examples because there's been different studies, there's different papers. And so anyways, that was fun. Why don't we, because there's a couple of us that I know are going to want to engage this for sure. Me, T-Rock, Mark Reid, Grayson, I'm sure for sure. Mark, did you want to take just some time to go over why you find the fusion argument significant? And that might be a good way to set the foundation for a bit of chat on that.
Just one
Yeah,
quick thing, one quick thing before we move on. I just want to share something, and then we can move on. Oh.
This is going to be
Go.
relevant.
Okay. This is the tree for algae. I think it writes itself. You know what I'm gonna say, but I'm not gonna say it. I just want them to see it. You guys, you get what I'm saying? You get the point? They have no transitionals. Let's move on.
Nobody gets your points.
So not relevant. Yeah. Okay.
Leaves the literally drop that and dip.
He did. He just dropped that and dipped.
That was the funniest look at the trees argument that I've ever heard.
I'm sorry. That's not funny. I'm sorry. That's just hilarious. I'm sorry.
It's-
Yeah. So what were you asking me? Something? Sorry. That totally just my mind is
Tell
blank
us
after
all
that.
about the trees, Mark. What are your thoughts on the trees? No, but in all
The
reality,
trees.
firstly, this has been fun, guys. So as we move forward, yes, what I was asking you was if you wanted to, because you brought up the chromosome 2 fusion in the first couple hours, but you didn't really
Yes.
have enough time to expound on it. So if you wanted to take a
Yeah,
couple minutes and go over
So
it.
it's head-to-head telomeric, the occurrence of telomeres head-to-head. So basically, we've got a chain of one sequence that is a telomere, and then the other sequence, which is a telomere fragment, right after it. So it is the endpoints of two chromosomes. And we can see the similarity between 2A and 2B in other primates like apes and chimpanzees and stuff like that. But there is a second fragment of a centromere in the lower half of that chromosome 2, and there is end-to-end telomeric fusion there. We can see it. So I just that to me is the most convincing thing about it, is that the sequence goes sort of one way and then it goes the other way, exactly as if it was two different chromosomes.
Okay, Mark, I appreciate that. What I want to do, guys, for this discussion is keep it as equally timed as possible. No one really interrupting each other. So whoever wants to get in on this chat, let me know, and we'll kind of go around the room like we did in the last open mic. So Mark, I appreciate that. Before I give a complete response, I would like to ask you a question. Do you hold to the same argument that Gutsy Gibbon does? She expounded it in her video, where she says that the chromosome 2, that 798 base pair region, that's the only place you find in the genome your sequences there, the TTAGG for telomeres and CCCTAA. That's the only place you find these in the genome in a mirror image.
Oh, in a mirror image. Yeah, I think so. I think that is the only place you'll find them. Yeah.
Okay.
He's trying to trick you. What he because
Well, no, Grayson, we're gonna go around. Okay, go ahead, Grayson. You go ahead.
Because he knows of smaller instances where you might have like one or two repeats of a head-to-head telomeric sequence, but like,
well, but Grayson,
the thing is that it's the
no, it's not a key thing because Grayson, you know, and I can pull up Erica's video. And in our debate, you said many times, it's the only place. It's the only place. And then I show you on multiple chromosomes because Chris Roop and I looked into it. And even Dr. Tompkins was fascinated. He's actually going to put out a paper soon on it, where we have multiple instances of TTAGGG, CCCTAA, the mirror image, on chromosomes that have nothing to do with a fusion. But you did say, and it's recorded in our debate, that no. It's the only place in the whole genome. Erica said it too, the only place in the entire genome. And I admit it. I said that is a point for the evolution model, because the evolution model, Joel Duff, I love the chromosome 2 topic. I challenge you to a debate on it if you would like to do that in the future. Anyways, and so the point is, and don't shift the goalpost, we have multiple locations, and I'll pull up just one right now. And one is the chromosome 9. Grayson, you're kind of silent. Talk. Did Erica not say in her video that it's the only place in the entire genome that we find those sequences? Don't shift the goalpost. Don't say, well, it's the number of sequences. That wasn't the challenge. The challenge was to show us one other area in the genome where we find these sequences. Go ahead. I want you to respond, Grayson.
Right. Well, I can't speak to what Erica said, but I believe that my exact quote was a little bit different than you're characterizing it there.
Go ahead.
I think my exact quote was, "I'm not aware of a sequence." That wasn't very strong as an absolute claim, but I do applaud you for actually going into the blast and actually going in and trying to find these sequence, or at least having Chris Roop help you do that. But I think that ultimately the point that it is the largest number of head-to-head telomeric repeats in the entire human genome is still completely valid, because your position would have to be that is just a coincidence. Like that's what your position would have to be.
Okay, let me respond. It's actually not, because we found, so what we discovered, and I'm trying to pull them up because I had all the chromosomes listed. It was actually the chromosomes that I predicted. So in our debate, and I'll pull up the slide. So in our debate, I went over some of the work I did. So here we go. So here's the chromosomes. Okay, 1 to 22 sex chromosomes. So here's the chromosome 2. These interstitial repeats, you can see them color coded. Okay, so here's the chromosome 2. We can see quite a bit of these repeats, but we also see quite a bit of repeats in chromosome 5. And notice how chromosome 2 is the biggest chromosome 2 as well. But yet we find quite a bit in I just want to make sure that this is the right diagram.
So how many of those other chromosomes have a second centromere fragment?
Well, the second centromere is a good argument too. That's a secondary one. So we'll get to that in a little bit. Okay.
Well, any of those other chromosomes have a
I was actually that other diagram I was just showing was a layout of the alphoid repeats. It's a very similar argument, the so-called cryptic centromere, and then also the ancient remnants of a fusion with the telomeres. They're very similar, and there's similar responses. So we'll deal with the telomere one first. So this is the telomeric repeat. So notice chromosome 2, again, it's the largest chromosome, but you'll find there's quite a bit of interstitial repeats, right? And they're all kind of in the middle. But wait a minute, there's quite a bit on 16. There's quite a bit on 21, 20. You can do a blast analysis and see this for yourself. Notice how many you find on 21 and 22. And yet those chromosomes are tiny compared to the chromosome 2. But these aren't associated with a fusion. And yet what do we find there? TTA, GGG, and other instances of CCC, TAA, the reverse complement. 16 has a lot. And I predicted in our debate, Grayson, I said, you know what? I wouldn't be surprised if we found those repeats that are supposedly signatures of a fusion in these chromosomes. And yet that's what we discovered. We discovered that you find them in mirror image, TTA, GGG, CCC, TAA in these areas. Okay. And as a matter of fact, in the chromosome 2 area, it's actually very degenerate. And what I mean by that is we don't really find the repeats, TTA, GGG. We don't find many instances of them in tandem order. We actually find in other chromosomes, we find more instances of them where they're in tandem repeat, where they're not degenerated. And so that's a uniqueness in other chromosomes versus the chromosome 2 spot. Anyways, here's the biggest site we found. So here's BLAST. You can see all the data here. And chromosome 9, large area where these repeats are all over the place. You can see here, large area, very similar to the chromosome 2. TTA, GGG, CCC, TAA, mirror image. Here's the chromosome 2 spot. So you have a few in tandem. 1, I highlighted them red. 2, 3, 4. And then here's the CCC, TAA. But it's very degenerate because there's really only a few in tandem. And what I mean is it's very broken. Look, TGA, GG. So you don't get one nice tandem until many letters in. So the point is we find this exact signature in many other chromosomes. Chromosome 9, we find the signature, and it's a large signature. So it's not just a few, like Grayson was saying earlier. It's very similar to the chromosome 2. And so I guess my question then is chromosome 9, is this a representation of an ancient fusion, Mark?
Could be. I don't know enough about it, but it could be. Does that have a centromere, a second centromere that's been deactivated like the chromosome 2 does?
Well, that's the problem is when you go to the cryptic centromere argument, there's no cryptic centromere found either. Those alphoid.
Let's not go to the alphoid yet. Let's not go to alphoid yet because you just talked for like 15 minutes. So
right. Well, and that's the thing.
What you said.
But again, this right here is the main argument because some evolutionists have actually just conceded and said, yeah, we don't really find remnants of a cryptic centromere. Because
before you move on, let's just address what you've already said before you start making new points, right?
Well, I allowed Mark to address it, but he went to the
brought it up.
Centromere. So whoever wants to respond to this, we find an nearly identical signature here in chromosome 9.
Can we just address that? I mean, you're going to
address it. Somebody address it. Quit whining.
I'm trying to address it, but you keep talking over me. Okay.
Mark asked a question about the cryptic centromere.
The number of repeats in chromosome 9. What is that? 9 repeats? You have like 6 going forward and 3 going reverse and head to head,
No.
right?
I'm just showing the mirror image.
Right, but that you don't have any repeats. Like, I mean, where's your repeats before that, right? And so then in the chromosome 2 example, I mean, there are a lot more than just 9 repeats there. That is a much larger sequence of forward to reverse telomeres in the exact place that it would be predicted we would find it if the chromosome 2 fusion did happen. So again, and this is what I already levied against you and you have not addressed, is that just a coincidence?
No, you don't get it. You don't get it. These repeats that we find, okay, there's now even in the secular literature, and this is what sparked the interest of Dr. Tompkins to actually look into it himself. These repeats, TTAGG, these interstitial repeats, CCCTAA, they're found everywhere in the genome. They're associated with functional roles. For example, gene expression, okay? This has been documented in the secular literature in at least one paper, and then Dr. Tompkins went and did the analysis himself, and he tested it all and looked for activity and all that, and he confirmed it, okay? So the point is that contradicts the argument from the evolutionist side that says, well, this signature is what we'd expect to find if this were the ancient remnants of a fusion. Then the response typically, like with Erica and then with you, maybe not as loudly and proudly as Erica, is, well, okay, we find these repeats everywhere in the genome, but never in mirror image. It's either TTAGG here or CCCTAA over here. But yet I find you at least 5 or 6 chromosomes that contradicts that argument, and one specific chromosome, chromosome 9, that is quite large, that contradicts that as well. And now you're shifting the goalpost. It doesn't matter. The chromosome 2, I've already shown, is a lot bigger. And so we find a little bit more of the repeats in chromosome 2 than versus chromosome 9. It's not a big deal. It doesn't help your case, is the point. Okay, you find these sequences everywhere. They're associated with function. There's a massive signature in the chromosome 9, has nothing to do with a fusion. The chromosome 2, nothing to do with a fusion either. Go ahead.
Right. Well, from the paper that I'm reading, sort of says that the indication of 9PTER, the chromosome 9, suggests that was a duplication before the gorilla chimpanzee human split. This is a very technical paper. I'd love for you to read it, but the divergence indicates this duplication predated the gorilla chimpanzee human split. Fish data would indicate a more recent date because only one location is labeled in gorilla and orangutan compared with site corresponding to both 9 in human and chimpanzee. So you're looking at a system where we have these duplicate inverted mirror expressions, as you've called them. The problem that you have is they exist in all other primates as well. They're all over the place in other primates as well, and they correspond to the ones in humans. Now, you might say design, that's fine, but the big difference is in 2, where we have the repeats, but they're not, like the repeats actually exist in chimps. They're just not fused together.
Well, Mark, I don't want to interrupt you, but right here, look at the image. Here's the repeats in the chimpanzee genome. Notice the massive differences. So we're finding that these internal telomeric-like repeats are associated with a lot of activity and function, mainly gene expression. Look at how many of these repeats exist in the human genome versus the chimpanzee genome. So no, there's not very much homology. It's actually very weak homology. The chimpanzee genome is quite different when it comes to these repeats.
Donny, yes or no? Has the chimpanzee genome been completely sequenced?
No, it's been weakly sequenced, and human genome's been used as a.
So then what you're showing on screen here, one is not showing head-to-head telomeres. That's what all of the graphs that you so far you've shown have conflated interstitial sequences with the head-to-head sequences.
But I went in deeper. Yeah, but I went in deeper.
Wait. You can't conflate that. But secondarily, we haven't sequenced the chimpanzee genome.
Yeah.
So
Okay.
showing us a graph like this is disingenuous because, like, especially for the non-coding areas of the chimpanzee genome where the interstitial sequences are, we definitely have not sequenced most of those areas. So this is not, I mean, your source for this is creation.com source.
But what we have sequenced, dude, are you serious? This screams desperation because you're using the argument. Yes, this is documented from a CMI research because PhD scientists went into BLAST, just like Chris Roop and I did, and got this data. Anybody can do it, and then just get a visual representation of it. Doesn't matter if you're a flat earther, a creationist, or an evolutionist. This is just sound data. Now, what we understand about the genome of the chimpanzee, yes, it's very weakly sequenced and understood when compared to the human genome. This is what we got. So are you predicting that once we sequence it more and understand it more and have a stronger representation of the chimpanzee genome, you think it's going to become closer to this? You're fine to make that prediction, but you don't have that data right now. The point is, we find these sequences throughout the entire genome. You can see we find quite a bit on 21, 22, 16. Yeah, chromosome 2, we find a lot too. It's also a massive chromosome.
Well,
and the chromosome 9, we find a very similar signature.
You got to stop
Very
conflating interstitial sequences with the head-to-head sequences that
But
are
I've already shown you.
signs of
when
a
you dig-
fusion.
Wait, no, you're slapping and running. When you dig deep, you also find the mirror image TTAGGG, CCCTAA on many of these chromosomes. I've
Yeah,
sent
but
you
you
with the
cannot
chromosomes we find
equate
on.
them. You are conflating them. That is an issue. Don't conflate them. When you're talking about head-to-head sequences, be careful to only be talking about head-to-head sequences, and don't conflate your statements to the larger interstitial regions, because that's like not accurate to do.
Okay, so let me respond. You find these interstitial repeats in all these chromosomes. Now you have to dig deeper, like we did here. Here's the documentation, and find out how many are intact, how many are degenerate. Because in the chromosome 2, in the so-called fusion site, you only find 10 intact TTAGG telomere sequences. In one of the main papers associated with the chromosome 2 fusion, the author said, why is it so degenerate? How are so many of these sequences basically lost and destroyed or corrupted over time? When it comes to the reverse complement sequences, you find about 43, and the region itself is only 798 base pairs. Chromosome 2, and we're still looking, guarantee we'll find more spots, quite a big signature as well. And so when you dig deep into each of these chromosomes, okay, surprisingly, you have quite a few spots where we've discovered that the mirror image, and yet nobody has suggested that those are there because of an ancient fusion event. And yet now we have a lot of research saying that these sequences and DNA elements are there for functional reasons. That negates a fusion, and we have a functional gene overlapping the area. I mean,
Well, I
it's
think
so
it's a
weak
bit
for you guys right now.
It's a bit it's absolutely weird. Like you can look at that and you can go, oh well, that's just a coincidence that those telomeric repeats happen at the exact point that the chimpanzees, like, you can look at their DNA and they almost fit together. I think you're being really disingenuous
No,
and
they
sort of
don't.
going, oh well, those things that that happens and those things happen. You're looking at sort of the actual, if you line them up, the actual similarity between 2A and 2B and 2 in humans is overwhelming. Like, it is so similar. It really is.
Okay, let me respond. That's an assertion. We've looked at the homology. It's very weak. One of the chromosomes is like there's 10% of it missing. There's a specific category of satellite DNA that's not around or found around human chromosomes, including the human chromosome 2. Lack of homology at the ends of the chimpanzee chromosomes 2A and 2B. We also find that thousands and thousands of sequences surrounding the 798 base pair region, okay, in the chromosome 2 spot, are not found in chimpanzee. And when you read that highly technical paper, you see that they're trying to explain it over time through duplications and translocations and genes in the human genome basically moving to where they are to explain why it's so different. No, it's very different. And now we find these sequences all throughout the genome, even in spots where we're looking at a mirror image. It's very degenerate at the so-called fusion site, but what we do find is associated with function. No, it's looking very bad for the fusion argument.
I just want to be very clear that
No.
600,000
Look,
claim of yours is completely fictitious. After our last debate, when you made that claim, I went back to the paper, I read the paper, and I asked you to cite the source for that, and you were unable to do so. So there is no claim that like what you just claimed. There's no source for that information. That is not true about that
So Grayson,
600,000.
have you read through that massive? Have
Okay.
you read through that massive paper? Because as you scroll down, they're talking about since the split, and they even have phylogenies there. I'd have to pull up the paper. And since the split, you have human, chimpanzee, common ancestor, roughly 6 million years ago. Since the split, they go over massive sections of that paper is saying duplication here, mutation here, translocation here. Why in the world do you think they're invoking all of those changes?
Yeah, you are misreading that paper.
They're trying to
if you think
explain
that they are
why
saying-
it's different.
Well, I
what you
put
think
the
that paper
paper
is saying
in
is absolutely not in that paper. That is your misunderstanding of that paper. So stop citing it unless you can find in the paper where it agrees with you. Which it doesn't.
Neither here nor there. It's agnostic. I don't care what you believe about it. The point is the so-called signature that you evolutionists have been looking to for years and years is found elsewhere in the genome. We actually find it elsewhere in the genome with more tandem repeats. It's less degenerate than at the
Hang on. I got to say something. Hold it. I've been very patient. Now, I've put in the chat the paper that I've drawn on my information from. So if you could give me a paper that says there was no fusion and this was something else, then please provide that, because you don't seem willing to be able
Mark,
to do
that is so dishonest.
Now, this actually says, no, shut up, Bubbles, shut up. You've got nothing to contribute. Go
Yes, I
away.
do.
So this is basically saying that there's a 98 to 99% average sequence identity. A 67 kb block on the distal side of the fusion site is highly homologous to the sequences at 22 qTER. Like, so everything that you're saying, that like we don't see homology at all, we don't see all that. Yeah, we do. And I've got the paper that shows it. If you would just read through the papers. But I think Grayson's right. You're Bubble, shut up. You're misrepresenting it.
Triggered, Mark.
Like, I see you having stuff in here. It's all from Answers in Genesis, which is a religious think tank. That's all it is.
Okay, now Mark just requested that Standing for Truth provide a paper stating that there was no fusion. No paper is going to say that, Mark.
Why?
Okay, Ken Miller literally said
because they all have an atheist slant, evolutionist slant. They all have an agenda. Of course, they're not going to say
there's Christian scientists, there's Christian geneticists. What are you talking
Mark,
about?
You don't care about those papers.
It is kind of disingenuous to ask for an evolutionist for an evolutionary secular paper to say there's no fusion. Dr. Ken Miller literally said if there's no fusion, just wait. Dr. Ken Miller said if there's no fusion, there's no evolution. Okay, the evolutionary community requires a fusion, and you're scoffing at creationist sources. Again, this was done by a couple of creation scientists. This was done just by myself and Christopher Rube, where we went in using BLAST, and we started with small sequences. We said, you know what? People like Grayson are insinuating, maybe not as proudly and loudly as Erica, but Erica is saying the fusion site is the only place where we find in mere form TTAGG, CCC, TAA, because the evolutionist rightfully concedes, yes, we find these repeats elsewhere in the genome, and they're associated with what? With function. But their response is typically, but the fusion site's the only place where we find them head to head. And so we went in and we suggested, and Chris Rube specifically did the BLAST analysis because he's got experience with that. And we said, let's start with small sequences, just one or two, TTA, GGG, CCC, TAA. We found them in many chromosomes. And then we worked our way up more and more and more and more. And eventually we found the chromosome 9 where there's a huge signature. It's associated with, it's a DNA element. It's associated with function, has nothing to do with the fusion, or else you're going to have to say that there's been fusions all over the genome. But no, you just want to say there's only a fusion in the chromosome 2 spot.
Donny, then why doesn't he publish it then? Publish it.
Oh yes, because if we publish
if it's so rock solid, no. This is the thing. You guys want to make it out like scientists are just going to stop and there's a big conspiracy. That is not the case. That's the point. Shut up, Bubbles. Come on, man. Like, seriously, I'm talking. What is wrong with you? Something wrong with you. Like if you discover this, then you should be working to get it out as soon as possible so it can be peer reviewed.
Here, let's do a thought experiment, Mark. Let's do a thought experiment, Mark. Let's say I do publish a paper.
What's your thought
let's say I publish a paper, and then Richard Dawkins gets to review my paper. Do you think he's going to review that paper unbiasedly?
Why would Richard Dawkins be reviewing papers?
Wait, you don't
Mary
think
Schweitzer
you don't think wait you
debunked
don't
your point
think
on this,
you
Bubble.
don't think he's capable of reviewing my paper somehow?
Bubble, Mary Schweitzer debunks this. She published
Grayson,
something that went
let's
against the
stay on the.
consensus, and
Yes.
she was allowed to publish something that went against the
Yes.
consensus. Mary
No, she didn't.
Schweitzer actively debunks you.
No,
Yes.
no, she didn't.
Now,
She
and Donny,
she's an
the
evolutionist.
This is the
main
most
point that
brain
you
dead
need to address,
conversation.
Donny,
No,
the
no,
main
the main
point.
point
you need to address. No, Grayson, the main point you need to
Why
address.
won't you
You've
let
been
me talk?
avoiding. You've
Why
been
won't you let me talk,
avoiding
Donny?
since our
The
debate.
main point that you need to address is the size difference. The
No,
size
no,
of
no,
the
no.
head-to-head
No,
telomeric
you don't get it.
sequence
Why
in
isn't the
chromosome
size
2
important?
is bigger
Why isn't the
than
size
at
important?
why is
That's
the
what
size
she
important?
said.
Yeah, why is the size important?
Because the size, as in the number of telomeric repeats that are in the head-to-head formation in chromosome 2 is larger than anywhere else in the genome. And
So
Donny was
weak.
showing that. He showed in
Grayson, so
chromosome
weak,
9 that
so
it's only a
soft.
few head-to-head sequences, but in chromosome 2 he showed that it was a lot of them. It was a much larger head-to-head sequence. So Donny needs to explain why the largest
what I
sequence
need to
would be
explain
at the
so I can-
exact fusion site predicted.
No, Grayson, weak and soft. Okay. Firstly, there's things
That's not
about
an
the
argument.
chromosome 2 that are unique to the chromosome 2, but then there's things about the other chromosomes that are unique. For
You're
example,
dodging.
the chromosome 2, I'm talking. The chromosome 2 spot is very degenerate. It's very small. It's very muddled. Okay. And when you actually look at it, you find a lack of unbroken telomeric repeats. Okay. You can look at it yourself over here.
It's
Don't
it's
talk-
state of degeneration doesn't matter.
listen, just because I'm going to another window doesn't mean that you can interrupt. Relax. Okay. So here's the sequence here. You can count them up yourself. The intact ones that we do find at the so-called fusion site, notice how they're primarily found independently or in isolation. That's because the other bases, they don't exist as tandem
It's
repeats.
state of
right?
degeneration doesn't matter.
GGG. Grayson, I'm going to use my famous line. The beginnings of your sentences are starting in the middle of mine, and you need to stop now.
I'm
I
addressed
understand,
everything
I
you
understand
said.
you're excited because you're being demolished. Relax. You'll have a chance to
I
respond.
already
okay?
addressed everything you're
You'll
saying.
have an listen, you'll have a chance to respond. If the 798 site within human chromosome 2 really is the ancient relics or leftovers of a fusion, we should locate thousands of these complete motifs
No, we
in
shouldn't.
near perfect tandem. We don't find that. We actually find elsewhere in the genome these internal telomeric repeats more than 10 times
Where?
in tandem. And so that's unique. Okay. Well, you can find it on, I believe it's 10, 11, 12.
Well, the one
Put in
you
the word
showed.
yourself, dude. Stop. You're interrupting me. I'm not done talking yet. Okay.
You
Now,
keep going on and
listen,
on and on.
Stop. Grayson, I'm going to kick you because I'm not in the mood for your attitude tonight. Okay. Listen, we find, contrary to what you've said and Erica says, we found these sequences, TTAGG, CCC, TAA, everywhere in the genome. And we found a spot in chromosome 9. Okay. Yes, it's more degenerate than the fusion site. Okay, fine. But it's still a very large signature. But notice here, this is what you're missing. The size of the human chromosome 2 is twice, sometimes 3 times the size of these sites, like chromosome 21 and 22, where we find a lot of these sequences in mirror image. So what? We find a little bit more in the chromosome 2. Who cares? You're grasping at straws. You're looking desperate. Give up the
That's
chromosome 2,
significant.
Grayson. Find another argument. Go ahead.
Okay, so you
That's
just
significant.
conceded my entire point by basically saying that the size is insignificant because it's a problem for your world view, and you're basically saying it's only a coincidence that the largest amount, like the largest head-to-head sequence is in chromosome 2. In your own presentation that you had just previously shown, you showed in chromosome 9, and you yourself said this is the largest sequence outside of chromosome 2 that Chris Roop and I were able to show. And you showed the sequence, and there were only 9 repeats in the head-to-head formation. You showed that on the screen. That is much smaller than the chromosome 2
So
area.
desperate. So shifting the goalpost from you're not going to find any of these anywhere. We find them
I never
everywhere.
said that.
You're not going to find a large one. We find a large one. Oh, the chromosome 2 is the biggest. Who cares? The chromosome 2 itself is 3 to 4 times the size of some of these chromosomes. And so there's a bit more in them. Who cares? They're associated with DNA function. They're associated with gene expression. This is a very weak argument from you. You're shifting. This is a logical fallacy that you're guilty of, Grayson, because you can't understand the data. It actually turns out that the fusion sequence, although it's larger, we find very few intact TTAGG and CCTAA sequences. We actually find elsewhere in the genome and other chromosomes where we find more intact. Yes, it's not as large as the chromosome 2, but we find more intact. And so that is unique for those as compared to the chromosome 2. Who cares?
Okay, so
If
Donny,
it's a
yes
little
or no?
larger, it's desperate.
Quickly, yes or no? Is it a coincidence that the largest head-to-head sequence is in chromosome 2? It's a yes or no. Is it a coincidence?
Is it a coincidence that this chromosome 2, which is how much larger than the chromosome 9, twice the size? So the chromosome 2 site's a little bigger than the chromosome 9, but it's also twice the size of a chromosome 9.
Oh, that's not true. That's not true. Could you share my screen, Donny?
Sure.
Let's see how much bigger it is.
But I just want to point out to the audience a lot of goal shift moving here.
No,
I've never
see
seen
how much bigger it is.
Literally, the first thing I said to you was the size, and I've stuck on that point this entire time. No
People
goal.
can go watch our debate, and you were very
Yeah.
unsure of yourself. You were repeating Erica's argument, trying to say it's the only place in the genome where we find them.
Okay, so now you're admitting that I didn't say anything with certainty, or I didn't make an absolute statement. So now you're admitting that I did not move the goal.
In the debate, you would make a statement that was very certain, but then I would ask you, like, "Are you sure?" But then you'd realize, well, you didn't look into yourself.
Okay, could we stop the meta?
So
like,
then
who cares about the meta? Like, seriously, like you're going into meta. Like during the debate, you were nervous. Like, come on, dude, seriously.
I didn't say you were nervous. When did I say that?
I just want to. Well, whatever. I just want to show the fusion site and just how big it is compared to the others, kind of thing, right? So, like Donny's sort of saying, "Oh, it's a little bit big." No, it's not a little bit bigger. It's like at least 3 times the size as any other site. And this is just coincidence.
Are you talking about Are you talking about the chromosome itself or the fusion site?
Fusion site.
Okay, so how many base pairs is the fusion site?
Not 100% sure.
It's 798. How many base pairs is the chromosome 2 itself? How large is the chromosome 2?
How large is it?
A lot larger than that. What's the point you're making here? What's the size of this site?
Well, I'm just saying that the size of the chromosome 2 fusion site is way larger than any other duplications that you're pointing to.
How large was this site in the chromosome 9, within the chromosome 9?
I just want to be very clear that there is no correlation between like the interstitial sequence length of repeats and the total size of the chromosome. So like that's a faulty assumption on your part.
All we find is these internal telomeric sequences. We find them in various chromosomes, including the chromosome 2. We now understand that these sequences are there for functional purposes. They serve important engineered purposes. They're not associated with ancient fusions. You want to say they're associated with ancient fusions, but there's nothing unique about the so-called fusion spot. We're just going to go in circles. I've documented it. I've put in the work. I'm showing it here.
Donny,
you guys can hold on to it.
We don't say it. It's the geneticists that say it. We don't say it. Like, it's not like we're going, oh, we've just come up with this thing to show our worldview right, kind of thing. And sort of this is what the scientists actually say who do the work on it. Like, you don't have to convince us. You have to convince them.
It was the scientists, Mark. It was the scientists themselves that when they looked at the area, the 798 base pair region, they're the ones that said and asked the question, why is it so degenerate? Why is it so small? Why do we find so few intact TTAGG telomere sequences? And they answered the question with some stories, some hypotheses, none of them all that convincing. Yeah.
Well, here's the thing. It's kind of like, why was it a prediction that we would find this head-to-head fusion there? Like, why is it that we looked at the DNA sequences and said, hey, they look like they matched up. Let's make a hypothesis that we're going to find a fusion site there. And then they found it. You know that this was proposed before they found the teramelic sequences, right?
Well, they use a type of comparison, a type of DNA analysis that kind of stains the chromosome, and so they can see similarities. And so even before they made the prediction, they could see that there were some similarities between the human chromosome 2, right, and chimpanzee
And
chromosome
2A,
2A and 2B.
Yeah.
There's some synteny there. And so they had to choose. T-Rock, is that you? You kind of sound like Mickey Mouse. Because I will say this, my wife, because I'm going on 3 hours and 10 minutes. My wife said my dinner was ready 10 minutes ago.
Okay, sorry. Yeah, no.
It's been fun. It's been passionate. It's been lively, but I always appreciate conversations with you guys. So why don't we allow now T-Rock? But T-Rock, you might have to jump out and jump back